In this lesson, we're going to discuss an overview of the course so you know what to expect as you continue on watching these videos. So, first, let's talk about the course objectives. Our first objective is that by the end of the course, you should be able to install and configure Ansible and write a playbook that utilizes Ansible key functionality. Now, don't worry if this seems daunting. We're going to create a foundation by discussing the YAML syntax and Ansible generally before we get into the business of writing playbooks. Our second objective is that you'll be able to implement Ansible best practices after watching these videos. So, once we begin our configuration lessons and discussing playbooks, listen carefully for when I casually drop best practice bombs, as these should come in handy. But just in case you miss it, there will be a whole lesson devoted to best practices as well. Our last objective is that you'll be able to recognize use cases for your own environment. I'll be peppering in examples of Ansible functionality throughout the course, so keep a close eye out for any functionality that might be useful to you. But also definitely check out our targeted lessons in the special topics section. Next, I wanted to briefly discuss the course contents. This section that you're currently watching is the introduction section. We'll cover the what of Ansible as well as an overview into YAML syntax before moving on to the next section, which is the setup process to configuration. Assuming that most of you do not have a dedicated Ansible setup ready to go, we'll start by getting a test environment created and then get Ansible installed and configured so we're ready to begin our journey into playbooks. After that, we'll begin running commands against our test machine, and we'll also write a playbook that utilizes various Ansible key concepts. Most of the lessons in that section will have accompanying files so that you can test out the tasks I create in the videos. So don't be afraid to begin playing around. We'll continue on in the next section with the idea of includes and more predominantly roles. Roles can seem confusing to a newcomer to Ansible, so I'll attempt to chunk out this topic by discussing includes first and then breaking down the directory structure to the actual process of creating a role. This section contains our first two-part video, so any of those you see should be considered one topic. After roles, we'll move on to some other key playbook functionality, including error handling, privilege escalation, and another two-part lesson on check mode and debugging playbooks. This will lead right into our special topics section. And the three topics I've chosen here are ones that I've been asked a lot about in the past. And I think especially Windows and EC2 dynamic inventory lend themselves better to a video demonstration. So hopefully you'll find them useful. And then lastly, we'll conclude with a quick overview of Ansible Resources, and we'll wrap up the course with an objective review. So in advance, thank you so much for watching these videos, and I hope you learn a ton about Ansible. We're going to be covering a brief introduction to Ansible. We will cover what Ansible is, the reasons why you may want to use Ansible, and lastly, some high-level use cases. So we'll start off with what Ansible actually is. There are three products that are generally associated with the Ansible brand. First, we have Ansible Core, which is an open source command line automation platform. Second, we have Ansible Tower, which is a web application that adds role based access control, centralized logging, and a REST API for your Ansible environment. And lastly, we have Ansible Galaxy, which is a website where you can go to browse a large catalog of community created roles. We will learn more about roles in a future lesson. However, this course will cover only Ansible Core. So if you're interested in looking into the other two Ansible products in more detail, feel free to visit Ansible.com for more information. So to begin, what are some reasons why someone would want to use Ansible Core? Ansible is simple. We expect that your user base is going to be mixed with people of all skill levels, and as a result, it's incredibly easy to get started. The language playbooks are written in is very easy to read, and those playbooks are going to work consistently across environments. It's also powerful in that we can manage hundreds or even thousands of nodes because of Ansible's easy agentless setup. All you need for your managed servers is SSH and Python 2.5 or later installed. And in the case of Windows environments, you need WinRM and PowerShell 3.0 or higher. If you're still here after my sales pitch, then you're probably going to want to learn about some Ansible use cases. The 4 use cases listed here are broad, but they are definitely the most common. So first, we have configuration management. With Ansible, we can enforce a baseline state for all of our infrastructure to ensure that our servers have the right packages, configuration files, services, keys, etc. Ansible can also do deployment, in which you're taking your custom code and pushing that out to your servers. This will go hand in hand with orchestration, as Ansible-Playbooks can ensure that the correct servers are targeted in the correct order at any given time. And finally, Ansible excels at provisioning new servers, which basically means spinning up a new virtual machine instance. Ansible has modules for many of the public clouds, including AWS, Azure, DigitalOcean, Rackspace, VMware, Google Compute Engine, and so on. In the case of Amazon, Ansible has over 50 modules alone, which is crazy. So, in the following lessons, you're going to be able to see all of these use cases in action, so stay tuned. We're going to be covering a brief introduction to YAML syntax. YAML, or yet another markup language, is a great foundation to learning Ansible because playbooks are written in YAML formatting. YAML is similar in format to JSON, but it's inherently easier to read and write. So, in order to learn the YAML basics, we're going to talk about comments, dictionaries, lists, and strings. So in my example file named YAML Overview.yml, with the YML extension indicating a YAML file, I start the file with 3 dashes to indicate the beginning of the document. This is actually optional, but it's so ubiquitous in practice that I like to have it in there anyway. Now, if you need to comment portions of your playbook, you would preface those comments with the pound sign. So I've started my document and I've added a comment. And most Ansible playbooks actually begin with a YAML dictionary, which contain a list of key value pairs like the following: name, Cheddar Charlie; occupation, cheese tester; state, Wisconsin. Excellent. And I can expand upon that by adding a YAML list. Now, all members of a list are at the same indentation level and they're prefaced with a dash and then a space. In YAML, it would look something like this: Gorgonzola, Brie, Swiss. In Ansible, this might look something like cheeses, Gorgonzola, Brie, Swiss. Now, I can also abbreviate this YAML list, and instead of having them on separate lines, I can put them inside of brackets separated by commas with single quotations. Now we've talked about YAML dictionaries and YAML lists, and the last thing to discuss are YAML strings. So strings in YAML are also different from JSON. Now, looking at my dictionary example at the top, both my name and occupation values have spaces in them. And this is okay, I do not need to quote those values. I only need to quote strings when they include YAML special characters like colons, braces, brackets, pipes, etc. And with Ansible, you're going to see this most commonly with variables. So something like cheese, my cheese, would need to be quoted because anything after the colon is interpreted as a dictionary. And so we want to keep that as a variable, so that's why we quote that. Now, if you do run into any syntax issues when you first begin writing playbooks, there are a variety of YAML debuggers out there that can assist. We're going to be covering how to set up a test environment to begin using Ansible. There are 2 main requirements for running Ansible. First, your control machine needs to be Linux-based with either Python 2.6 or 2.7 installed. Second, your managed machines need to have Python 2.5 or later installed, or at least 2.4 with the Python simple JSON package present. As long as your control machine and managed machines fit these requirements and you are able to communicate with them via SSH or WinRM, then you should be able to successfully run Ansible. To set up a test environment, we have a couple options. We can either get access to a Linux virtual machine through a public cloud service like Amazon or Rackspace or VMware, or if you'd prefer not to spend money on a public cloud, then I would recommend utilizing Vagrant. Vagrant is an excellent open source tool that we can use to create a virtual machine right from our laptops, and then we can run Ansible from that. To get started installing Vagrant, you first need to have VirtualBox installed on your machine. You would grab the appropriate download package from virtualbox.org/wiki/downloads. Once the file finishes downloading, follow the prompts for the installation to complete. Then download Vagrant from vagrantup.com/downloads. Once that file finishes downloading, follow the prompts for the installation to complete. The installer file should automatically add Vagrant to the environment path, so you'll be able to use this from a terminal window right away. Since this process can take a while depending on your internet connection, I've decided to skip to the finished product. So now we can add our Vagrant boxes. There are two standard Vagrant boxes provided by HashiCorp that we can utilize for our Ansible test environment. First is an Ubuntu 14.04 machine. We create the box by running the commands listed on this page. So the first one, Vagrant init Ubuntu/Trusty64, and then we run Vagrant up. This process can take a couple minutes. So in my terminal window, I have already gone through this process and just to show you what it looks like when it's successfully completed. The second machine is a CentOS 7 machine that we can create by running the commands listed on this page, which is Vagrant init CentOS 7 and then Vagrant up. So I'm going to just transition to my terminal window. And as you can see, I created a directory called Ubuntu Trusty 64. And then inside that directory, I ran Vagrant init Ubuntu Trusty 64, which created a Vagrant file inside this directory. And then I ran Vagrant up, which imports the base box Ubuntu Trusty 64. This is how it looks as it goes through the process. And then it'll show that it has completed. At this point, I can now SSH into this machine. Now, if I were to do this from scratch and go over to my other tab here, I could run Vagrant init CentOS/7, which creates the Vagrant file, and then I can run Vagrant up. Now, it takes a while for the box to be downloaded. That's why I wanted to show you in the other tab what it looks like when it has completed. So while that's importing, I'm going to go back over to this tab and I'm going to run Vagrant SSH to SSH into the box. And now I'm successfully SSH'd into my Ubuntu Trusty 64 box. Now it's your choice as to what flavor of Linux you'd like to utilize to follow along. I'll probably show both distros in following lessons, but again, it is entirely up to you. Now that we have set up a test environment, we're going to cover how to install Ansible. I'm going to utilize both Vagrant boxes we added to demonstrate the different steps necessary to install Ansible. First, we'll start with our Ubuntu 14.04 machine. The first thing that I need to do to install Ansible is I need to add the Ansible PPA, and I will do that with apt-add repository PPA Ansible/Ansible. Press enter to continue, and then that completed. Now I'm just going to run an apt-get update on my machine, and that should only take a minute or so to complete. Perfect. And now that that's done, I can install Ansible with apt-get install Ansible. I'll press Y to continue, and now Ansible should be installed. I'll confirm that the latest Ansible is installed with Ansible version, and Ansible 2.0 is the latest version. Now, if I move over to our Cent 7 machine, there are actually some additional steps necessary. First, we need to add the EPEL repository, which we can confirm current listing by running yum repo list. And I currently do not have the EPEL repository present. We need to add it by downloading the package and then installing it. So I'll go ahead and download that by running wget https dl.fedoraproject.org/pub/epel/epel release latest noarch.rpm. And just a quick aside, if you don't have the wget package installed, you can install that with yum install wget. So now that I have the EPEL package, I'm going to install it by running rpm-ivh and then EPEL release latest 7 noarch rpm. Now I'm going to confirm that it's there with yum repo list. And you can already see that the EPEL repository pieces are showing up in the output, which means that we are good to go. And now at this point, we can run yum install Ansible. I'll run yes to continue, yes again, and now that's complete. Now, if I run Ansible version, the latest version of Ansible is not displaying here, and this is because the latest version of Ansible is currently in the EPEL testing repo. So this is going to change in the future, but for now, we do need to enable that repo to get up to 2.0. And for uniformity's sake, we should enable that repo as we're going through these lessons. So to do that, I'm going to run yum -config -manager -enable Apple testing. And so if you just scroll up a little bit, it shows you the information for the repo. Now I can run yum upgrade Ansible, Y to continue. And now if I run Ansible -- version again, I am on latest. We're going to be covering how to configure Ansible now that we have installed it. As I mentioned in a previous lesson, Ansible is agentless, which means that the main requirement for running Ansible is that you need to be able to communicate with your servers over SSH. To do this, we need to place an SSH public key in the authorized keys file of our remote host. But you can also utilize a private key file or PEM file as well. Now, up to this point, we have been utilizing Vagrant images as our control machines. However, we now come to the crux of what Ansible is about, and that's managing hosts and automating actions against them. So we now need to get a host to actually manage. I wanted to run you through the options you have for managed hosts. Basically, if you're already running a Linux machine locally, like a Mac or an Ubuntu laptop, then you can install Ansible as a control machine right away. And then you can utilize Vagrant as your managed hosts. However, if you're running a Windows laptop, then you're most likely installing Vagrant to use that as your control machine. This means that we now have to find a host to manage. Because Vagrant images managing Vagrant images can become complicated, the best way forward in order to follow along with the lesson is to either target locally, meaning that any action that we run is going to happen on the Vagrant box itself, or alternatively, we can utilize a free tier virtual machine through one of the public cloud providers like Amazon. To start, I'll show you how to target locally, but I will also show you primarily how to target a machine through AWS. To continue with the latter option, the first thing that you need to do is to sign up for an AWS account. You would go to aws.amazon.com and sign up for a basic account. You can then launch EC2 instances using the free tier option so that you can get practice with Ansible. The only catch is that you can really only run one instance per month, so I'll demonstrate that here. Once you've signed up, you can now select EC2 from the dashboard and select Launch Instance. I selected a RHEL 7.2 AMI and configured the instance details. The important part of this is your PEM file. Once you have that downloaded, you can create a file of the same name on your Vagrant image. Make sure that it's publicly viewable, and then you should be able to SSH to your instance. Now that this is complete, we can utilize Ansible to talk to it. Because we're using a PEM file instead of a public SSH key, we're going to tell Ansible that in the Ansible configuration file, which we're going to cover in more detail in a future lesson. First, we're going to navigate to Etsy Ansible, and then you're going to open up Ansible config in an editor of your choice. Now, I've already modified the file, but the parameter you're looking for is private key file. In this parameter, you're going to place the path to your PEM file so that Ansible knows that you're going to be utilizing a private key instead of a public SSH key when you run commands. Now, once those changes are saved, go anywhere in your Vagrant image and create a directory to house your first project. I created a directory called My Project, and inside, I created a hosts file with the information about my EC2 instance that I launched in Amazon. We're going to go into more detail in host files in a future lesson, but for right now, the only thing that you need to know is that I'm going to be targeting just this one instance, and I have the public IP address listed here in any format. So now I want to test whether Ansible can talk to it, and for that, I'll run an ad-hoc command. Again, not to sound like a broken record, but we're going to go into more detail on ad hoc commands in a future lesson. So to run an ad hoc command, you use the Ansible command. So Ansible, you're going to tell it which hosts you're going to target. In this case, I'm just going to say all because I only have one host. I'm going to specify the hosts file with the -I flag for inventory. I'm going to tell Ansible which user I'm connecting to this host as, which is EC2 user. And then I'm going to pass it a module argument, as in which module I want to use in this command. In this case, all I want to do is just to test whether I can talk to it. And for that, I'll use the ping module. Once this is all listed out, then I can press enter. And if everything goes successfully, then I will get a pong back. And that means that I have now successfully configured my control machine to talk to a remote machine. It only takes a second or so. And perfect. I get a success message, which means that I have now successfully configured Ansible. In today's lesson, we're going to focus on setting up a manual inventory. By default, when you install Ansible, a host file is created in the etc Ansible directory. I don't actually use that file because my personal preference is to actually create a host file inside of my project directory and manage it from there. That way, I don't have to supply a path when running a playbook, and it's alongside any host pairs or group pairs that you have, so they're easily located by Ansible. However, you are welcome to check out the default file as it contains examples that you can reference if you'd like. First, an inventory file is an INI or any format. Here I have a blank host file and I can start adding inventory elements right away. Now, there are some things to note. Comments are made with the hashtag just like in YAML. So I'll go ahead and add a comment now called making a comment in my host file. Blank lines are ignored, so feel free to make it pretty with line breaks and such, which I prefer to do as it can get pretty cluttered, especially if you have a large number of groups and hosts in here. And lastly, you can also utilize IP addresses or host names for your servers. So both are absolutely fine and can be used interchangeably. So if I wanted to add a group with a single host inside of it, I would utilize a header element like so to create a group called test server. And inside of that group, I would write out the IP address of my host. So this is an example of just a single host inside of a group. Now, I can also place a single host outside of a group. They don't have to be inside of a group, and that could look like something like this. And again, this would be an example of utilizing a host name over an IP address. Now, in terms of the group, you can have as few as one host in a group or as many as you need. So right now we only have the one, but if I wanted to add a second host, and if I also wanted to use a non-standard SSH port for that host, I can append that right to the end of my host name. And that would look like the following: test1.example.com, just use a colon, and then I would put the non-standard SSH port at the end. You can also use patterns if you have multiple hosts that follow the same format. So here I have a group called web servers, and I have 50 Apache web servers that follow the same sort of naming convention. And so to make it easy on myself, I could write Apache with some brackets and the range that I want to cover, like so. So leading zeros can or cannot be included. It's up to you, but the range is inclusive. So this would be from 1 to 50. I can do the same thing with some Nginx hosts to go from 50 to 100. This does work for alphabetic ranges as well. So if I had a group called app servers, I could do something like app A through F .example.com. And so that way I don't have to write everything out. So one of the big common use cases with an inventory file is to be able to specify connection and user information alongside your host. So in the case of our test server that we pinged previously, one thing that we can set in the inventory file is the user parameter, so I don't have to specify -u flag in my ad hoc commands. And that would look like Ansible_user is equal to EC2-user. Or in the case of Ansible 1.9 and earlier, that would be Ansible SSH user is equal to EC2 user. And so this prevents me from having to pass the -u flag every time I run an ad hoc command, which is useful. Placing the user parameter alongside the host name is actually an example of setting a host variable. If I had multiple hosts inside that group and they all had the same user setting, I could set a group var like so. So I would add vars inside of that header element and then set the same setting right there. So the Ansible user is equal to EC2 user. Now, actually, I'm showing you this, but best practice is that you don't set variables in inventory and you actually break out group vars and host vars into their own files. Now, this is something that we're going to cover more in a future lesson, but for now, this concludes our quick lesson on setting up manual inventory. In this lesson, we're going to talk about the Ansible configuration file. Ansible config is placed by default in the etc Ansible directory. However, you can also place an Ansible config file in the following places: as an environment variable, which in this case, I have it set to the temp directory, in the current directory, which in this case is the my project directory, in the home directory, and lastly, in the default location of etc Ansible. Now, just like with my host file, I typically place an Ansible config file right alongside my main playbook. This means that this file will take precedent over any Ansible config files placed in either the home directory or in the default location of etc Ansible. Precedence in Ansible is a big concept, and we're going to be exploring this more in a future lesson. Now, because there are so many parameters inside this configuration file, I'm only going to cover a few of them. As new users to Ansible are probably okay to just leave the defaults of this file and only change the values if necessary. There are 7 sections in the Ansible config file, and they cover everything from general defaults to accelerated mode and open SSH settings. In this lesson, we're only going to discuss a few parameters from the general default setting. However, we will delve into privilege escalation in a later lesson, which is also a section in this file. Now, looking at the configuration file, you'll notice that many of the default parameters are commented out. So most of the time, you really don't have to interact with this file if you don't want to, but the following parameters might be useful to you if you're interested in exploring this file. So to start with, any of the ask pass parameters are going to allow you to input a password at runtime. So this is super useful if you don't want to keep password information in VARS files and would rather be prompted to input the password when you run your playbook. Our second setting is the fork setting. By default, this is set to 5, and this controls how many parallel processes are spawned against your remote hosts. Raising this to a higher number is useful if you're running a playbook against a large number of hosts because it allows your playbook to complete faster. Now, our inventory is relatively small, so we're actually going to leave this as is and not even uncommented out. Okay, so the next setting is the library setting. This is the default path that Ansible uses to look for modules, and this can be modified to point to custom modules or to point to a devel version of a module that you're testing maybe new functionality with. The next setting is probably my most favorite, and that's the no cows parameter. If you uncomment the no cows parameter, then you're going to get a treat when you run your playbook. I have it set to 0, which means that now my playbook is going to be displayed an awesome cow say. And this is kind of the fun part of running playbooks. So I definitely recommend uncommenting this and having cow say in your playbooks. It's just fun, and we'll see it in a future lesson. The next one is the private key file parameter. And in our previous lesson, we actually supplied our path to our PEM file so that we're able to connect to our EC2 instance. Moving on, we now have the remote underscore wildcard setting. So that's remote underscore user, port, temp. And most of the time, these are usually set in your inventory file or in VARS files along with your playbook, but you can set them in the Ansible config file as well. If I were to uncomment this particular parameter, that would mean that I would be connecting to my hosts as root user by default. The next parameter is the timeout setting. And this controls the maximum amount of time to wait for an SSH connection to happen. So this may actually be worth ratcheting up in long running tasks. Okay, lastly, transport. The transport parameter by default is set to smart. which will use SSH-based connection if the open SSH versions on the target host are new enough. But if they're not, and I would say probably anything below 6 would not be new enough, you should explicitly set this to Paramiko. Now, this, of course, is only 12 or so settings out of many in the configuration file, so it may be worth it to familiarize yourself with some of the other parameters if you have a specific use case. Previously, we ran a command against our EC2 instance to make sure that we could talk to it. That's an example of an ad hoc command. Or, in other words, it's a good precursor to the playbook language in that we can just fire off a command that we don't necessarily want to save for later. So, what are some examples of ad hoc use cases? Pinging a machine like we did previously is a good start, but you can also manage packages, services, users, and groups. You can gather facts, copy files, and really do any sort of shell operation from your control machine that you'd like. The structure of an ad hoc command always starts with the Ansible keyword. You then tell Ansible which hosts you want to target, either all to target all of them, a single host, or a group of hosts. In this case, we only have one host, so we can either use all, target the IP address, or target the group name. I'm going to target the group name since it's easier to remember, and that is test server. You then have to tell Ansible which host file you're going to use by passing the -I inventory flag. Make sure to supply a path if your host file is not in the same directory as where you're running the command from. And then I tell Ansible which user I'm connecting with the -U flag. To avoid typing this out each time, you can actually set Ansible_user in your host file or in your Ansible config file as well. So after you specify the user, you then tell Ansible which module you want to utilize with the -M flag. And in this case, I will select the setup module, which is a really handy module to use with ad hoc commands because it allows you to gather facts about your remote hosts that you can then utilize as variables in your playbook. So I'll go ahead and run this, and it usually takes just a second. And just kind of scrolling up right away, you can see I get things like node name and IPv4 addresses and things like that. But probably one of the most common variables that you can utilize in your playbook are the distribution, major version, and the distribution. These are really handy if you have similar inventory. So if I had rel 6 and 7 hosts, I could filter down to only target either 6 or 7 by using a conditional statement when Ansible distribution major version is equal to 7. And we'll kind of see this more in a future lesson. So another example of a ad hoc use case is the ability to install packages with the yum or apt module, depending on your target OS. Except the big difference between this and the setup module is that I now have to supply arguments to the command to tell it which package I want to install and what state I want it to be on the target host. So I'll do that with the -A flag for arguments. So Ansible test server -I hosts -U EC2 user -M yum -A for arguments. And then I'm going to put these in quotes because there is a space between my key value pairs. And I'm actually installing the Apache package, the latest version here. And since we're installing a package, we need to make sure we can do this as root. So we'll add a -B flag at the end to become the root user. So B for become. Before I run this command can either take a couple seconds or it can take a little bit longer than that. We'll kind of play it by ear here as we're watching it. Perfect. It completed. I get a success message and a change true indicating that the package was installed on the target host. And now this brings up the perfect time to talk about item potency, which is a big Ansible buzzword because it means that actions happen once and only once. So in the case of this ad hoc command I ran, I can continue to run that over and over, and the Apache package will still only be installed the one time. So you can see in the return here that I get a changed false and it says all packages providing HTTPD are up to date. So another use case would be to make sure a service is started, and we can use Apache since we just installed that. So for that, I would use the service module and my ad hoc command would look like Ansible test server -I hosts -U EC2 user -M service -A name equals HTTPD state equals started -B at the end for become. And I get a change true and the state has been set to started. So now Apache is officially up on my target machine. Now, again, with that item potency principle, I could run this command over and over and Ansible will still only start Apache once. Up till now, we have been targeting our remote machine with our ad hoc commands. But if you have yet to get a managed host to manage, you can practice targeting locally. And this simplifies the ad hoc command a bit as I now just have to supply localhost as my target host, and I don't have to supply an inventory file. I also don't have to supply a user since this action is happening locally. So I can ping Ansible localhost -m ping. I get a pong back right away. I can gather facts, which I get a different sort of facts because this is a Debian host. And I can even check the uptime on this host if I wanted to, and I get the uptime back right away. So the above examples are just a small sampling of what you can do with the Ansible command, but it is a good rule of thumb to put tasks in a playbook that you may want to repeat again. We're going to be covering where you can go for help with Ansible on the command line. This might be a niche use case depending on your preference, but since you can do pretty much anything else from the command line, I thought it might be useful to cover how to get help with a module while you're there. The keyword for this is the Ansible-Doc command. If I want to get help on usage, I can run Ansible-Doc-H, and it gives me a list of options. You can see that you can get a list of modules with the -L flag, which I can pipe grep to find something specific like Ansible-Doc-L pipe grep EC2. And once this returns, this will give me a full list of all of the EC2 modules. Or I can use that same command and use the keyword win, which after this returns will get me all of the Windows modules. You can also just ask for the parameters of a single module by running Ansible-Doc EC2 underscore ENI. And then I can search for a parameter by doing / security underscore group, or I can just look through them one at a time. There are a couple other options available with Ansible-Doc command, but I think getting a list of modules and looking at the various parameters of a single module are the most useful. Playbooks are the building block of all the Ansible use cases that I mentioned previously, as we can now do configuration management, orchestration deployment, and provisioning all from a single playbook. Playbooks are written in YAML format and are structured using things called plays. There can be one or more plays inside of a playbook. However, today we're just going to start off with an example of one play. You'll see that I have a file ready to go called mariadb.yml. I'll just open that up and get started. To begin, we have our 3 dashes to start our YAML file. And then best practice is to name your play so that someone else coming in knows immediately what we're going to do in this playbook. I'll name mine Install and Configure MariaDB. Then we have our host declaration line. Just like with an ad hoc command, we can choose to target all of our inventory, target locally, target a group, or a single host. I'll continue as I did before and target the group name, which is test server. Then you tell Ansible which user you're going to connect as, which in this case is EC2-user. You don't have to specify it here if you've already specified Ansible underscore user in either your inventory file or in a VERS file somewhere. We can then decide whether or not we want to do root level operations on the target machine by setting become to yes. This is an example of privilege escalation, which we are going to talk more about in a future lesson. I'm also going to include a var section here because I am using a variable in my template file later. So I just need to indent a few times, and then I'm going to set my SQL port to 3306. Now the next part of a play is the task section. Tasks are executed in order from top to bottom, and they can be run at any time if a failure occurs. This again goes back to that principle of idempotency. If you get 75% of the way through the playbook, experience a failure, and then rerun, it's not going to execute those earlier tasks again. They'll just be skipped. Now, the only exceptions to this are the command shell and raw modules, but with the first two, you can add a creates flag to keep idempotency. So just like with our play header, we'll want to name our tasks. And my first task will be to install MariaDB, which I will do using the yum module. So yum, name of my package name, which is MariaDB-server, and then state equals latest. And then our next task, since this play is also about configuring, would be to push out a configuration file to our managed host. And for this, I would recommend using the template module, as we can actually access those variables we fact gathered using the setup command. In this case, however, I'm just using a standard configuration file with one variable in there for the DB port, and I will show that file in just a bit. So I'm going to name my task MySQL configuration file template module. Set the source equal to my.cnf.j2. The source is where the file lives locally on the machine running Ansible. And then the destination is where you want it to go. So my.cnf in the etc directory. And then I'm going to include a notify here to restart the service. So before I move on, typically when you push out configuration changes, you may want to restart the services if the file does change. And that's why I included this notify task. This is going to trigger at the end of the task block, and it's going to happen only once. So I can include multiple notifies that do the same thing, and it will still only happen the one time. Now, the task inside the notify is called a handler. Handlers are special tasks that only happen if a notify notifies them. In this case, MariaDB will not get restarted if there are no changes made to the my.cnf file. The important thing with this task is that we need to have a my.cnf.j2 file in the same directory as our main playbook since I didn't supply a path. Now, moving on to our third task, I need to configure the log file in order to get the service to start. And so for that, we're going to use the file module. And I'm going to provide a path to the file module, which will be var log mysqld.log. So that's where I want the log file to go. I'm going to create it with state equals touch. And then I'm going to do some permissions. So I'm going to set the owner to MySQL, the group to MySQL, and the mode to 0775. So those are my chmod permissions of the file. So then our last task before we handle the handler is to start the service. For that, I'm going to use the service module, and I'm going to give it the service name, state equals started, and enabled equals yes, which ensures that the service starts on boot. Okay, lastly, the handler section. So every time I have a notify in a playbook, I have to have a corresponding handler section so that the notify has something to notify. And in this case, I said that I wanted to restart the service. So I'm just going to do restart MariaDB. And it's pretty much the same as the service task right above, except I'm just restarting it. And just kind of taking a quick look, making sure my syntax looks okay. Great. So now I can actually go ahead and run this playbook. And before I do that, I did just want to cat this template file for you to see. It is a standard configuration file, and the only thing that's different here is the MySQL port is a variable, which I've defined in the var section of my playbook. So to run the playbook, I could do Ansible-Playbook, specify my hosts file, and then the playbook that I want to run, which is mariadb.yml. So I'll press enter. It's going to start off by gathering facts, which happens implicitly. Then it's going to install MariaDB, just like we specified in the playbook. And then once that completes, it's going to move on to the other tasks. So MariaDB has been installed. We have pushed out our configuration file, and we have created the log file. And now all we need to do is start the service. Now the handler kicks off to restart the service. And once that's complete, then the playbook is complete. And as you can see, we've got okay on all 6 of the tasks that we have in here, changed on 5. And again, just going back to that principle of idempotency, I could run this again. And then all of those tasks would now change to okay, and the handler would not even run because no changes were made. Variables in Ansible are used to account for differences between servers. By using variables, I have the ability to keep a nice layer of abstraction in my playbook and define my variables as I need to in various host or group vars files. There are innumerable use cases for variables in Ansible, so I'm only going to cover a few of them today, and then it's up to you to continue to learn after. The first thing that we need to cover is variable precedence, which is basically how your variables overwrite each other if you have them defined in multiple places. As of 2.0, there are now 16 levels of variable precedence. I've listed them here in this slide in order of overwriting ability from 16, which is role defaults, to 1, which is extra vars. Up to this point, we've briefly talked about host facts, which is information gathered about the remote host using the setup module. We've talked about setting inventory host variables like Ansible_user, and we also set a play variable when we set the MySQL port to 3306. You can see that there are still several vars options that take precedent over those 3, ending with extra vars, which will always take precedent over any other variable set. This can seem confusing when you're first starting out, But generally speaking, you should try to set your variables in as few places as possible to ensure that your variables don't step on each other accidentally. In future lessons, we'll see variables placed in a couple more locations, so stay tuned. Now that you have a general idea of where to place your variables, what are some use cases for them? Probably the most common use case is to use variable substitution inside your playbooks. Variable substitution is pretty much what we've already done in our mariadb.yml file. In my var section, I defined a variable that is located in my template file. However, I can also do this in tasks, like with my log file task. I can set that path to a variable and define that in my var section. So this would look like log path, and then I would go up here and define that variable as varlog. Now, if I don't want to keep these variables defined in the playbook, I can actually have a variable file alongside my playbook and define them there. So just exiting out of this file, I have a file called mariavars.yml, and I define those two variables in that file, and those are the only things in there because this is just a vars file. So now if I actually want to use this file, I would go back to my main playbook, and then I would change the vars section to be vars_files, and then I would get rid of these two variables because I no longer need to define them here. And I would just put the name of the file that I want to use, which is maria_vars.yml. Now, the concept of vars files, especially with sensitive data, will be explored in more depth in a future lesson. So, continuing on with variable substitution, I can also set my host line to a variable with something like hosts, my hosts, and then I can define the host I want to use at runtime. So, if I exit out of this, I could run Ansible-Playbook-I hosts, mariadb.yml, and then pass extra vars hosts equal test server. And then if I ran this, it would basically be like I was declaring that host inside the playbook, except I'm passing it as an extra var. So it's going to take precedent over anything else. This is super useful if you have a large number of hosts and you want that flexibility to not have to modify the playbook each time you run it to target different inventory. Okay, so another variable use case is registered variables. This is commonly used with the shell and command modules, so we can utilize the output of that command as a variable later. So I created another file called varcases.yml. And if I wanted to do something in a task like check the date on the server and then register that output and then print it out with a debug statement, I could do something like get date on the server, and then I'm going to use the shell module and put the command in. So that's date. Then I'm going to register the output of that. So use the register keyword. So register output. And now I'm going to print that out. So debug message equals the date is variable output dot standard out. Now I'm not going to run this just yet, but when I do, the output of that task should say the date is, and then whatever today's date is. And registered variables are seen a lot with conditional statements, and we're going to explore that as well in a future lesson. So the last use case we'll talk about today is variables gathered from fact data. Now remember that we can get all sorts of facts by using the setup module, and this is going to happen automatically in a playbook unless I set gather facts to false. Now I can print out the vars that are gathered by using a debug statement. And so this would look something like debug var equals Ansible_distribution_version. And then that would output the distribution version of my host that I'm targeting. Now, facts, just like registered variables, are also commonly used with conditional statements. But for another use case, we could use facts to group certain machines together temporarily for the duration of the playbook run. And we would do that with the group by module. So another task I could do, group some machines together temporarily, and I'd use the group by module there. Key equals rel underscore, and then I'm going to use that same fact as a variable here, distribution version. Close my curly braces. I'm going to register the result of that, call that group result. And then I'm going to include a debug statement to debug the output of that var. And so now after this runs, I would have a group that I can target easily. And this is probably only useful if you're trying to group together a subset of hosts and less useful with one host, but I did want to show it to you anyway. And before we run this, this was an example of using Ansible facts, but you can also use custom facts or local facts in FAXD as well. So I'm just going to exit out of this and then run that var cases playbook to show you how everything looks. So it's going to gather facts to start, and then I'm going to get the date on the server. And now the next task was the debug message, which shows me the date, which is Saturday, March 5th. I get my Ansible distribution version, which is 7.2. And then I've got my ad group, which is rel 7.2. Just like in a programming language, we can control our playbook flow by using various conditional operators. This all starts with the when statement. The when statement is most often used to decide which tasks you want to execute on certain hosts. For example, let's say that I have a mixed inventory that includes both Ubuntu and RHEL hosts. If I have a playbook that has certain tasks that won't work on one or the other, I can use the when statement to make sure that Ansible does not try to execute on those hosts by using the Ansible OS family fact variable. That would look something like, we just go down to my task here and name it don't install on Debian machines. Yum name equals HTTPD state equals latest. And then I'll include my when statement here as Ansible underscore OS family and set that equal to Red Hat. Now I can also group conditional statements together by using the AND operator. So I can modify this existing when statement and just put it inside parentheses and just include an and in between and do Ansible underscore distribution underscore major underscore version equal to 6. And this is going to ensure that that task is only going to take place on RHEL or CENT6 machines. So another example would be to run a task if a variable's Boolean value resolves to true or false. So in my var section, I set unicorn to true. So my task could look something like name, are unicorns real or fake? Shell echo unicorns are fake when not unicorn. Or alternatively, when unicorn for the true equivalent. So this task should skip because I have defined unicorn to be true and not false. So you can also use a when statement apply to situations where a variable is or is not defined. So for example, I can have a fail message display if a variable happens to be undefined, and that would look like fail message equals unicorns require rainbow variable to be set when rainbow is undefined. So because I have not defined the rainbow variable, this task will fail. It'll stop the whole playbook. So I'm going to comment it out for now, and we will move on to the next task. Previously, I had also mentioned that register variables and conditional statements tend to go hand in hand. So a couple examples of that would be I can test to see if SE Linux is running. I'll do shell get enforce, register the output of that command as SE status. And then I can use that registered variable later on with a conditional statement like configure SE Linux if not enforcing. And then I'll do SE Boolean, which just toggles SE Linux Booleans. Name equals MySQL connect any, state equals true, persistent equals yes. And then my when statement comes in when SE status.rc, so the return code, is not equal to 0. So in this case, I'm only going to configure SE Linux to start MySQL on any port if the return code is not equal to 0, meaning that SE Linux is not enforcing. So another example I could use of a registered variable with a conditional statement would be to print out log details if the log contains a certain phrase. So my task could be checking systemd, shell cat var messages, register those results as log underscore output. Then next task, shell echo systemd knows when we're doing Ansible stuff. When log underscore output dot standard out dot find, because we're looking for keywords inside of the messages log. I'll use Ansible as the keyword, close my parentheses and do a dot not equal to 0. I'm going to register the output of that as shell underscore echo. And then I'm going to do a debug to print that out. Perfect. So now I can actually run the playbook. Ansible-Playbook-ihost conditionals.yml. So it's gathering facts. It's skipping that first task because we have a rel 7 target host. So I'm just going to scroll back up here since it finished so quick. It skipped the second task because unicorn was set to true. SE Linux is running, but the next task is skipped because I only wanted it to configure it if it wasn't enforcing. I was able to successfully cat the output of verilog messages. The next task completed, so it was able to find that Ansible keyword, and then as a result, I have that in my standard out here in the debug messages. Loops are a shorthand way to do multiple tasks in one, whether it's installing packages or some other action that you need to do many times. There are many different loop options in Ansible, and just like with variables, I'm only going to cover a few of the most common use cases today. The most common use of a loop in Ansible is something called with items, which basically just iterates over a list of items. In my own playbooks, I use with items a lot to install multiple packages in one task. Now, if you take our mariadb.yml file, for example, we can add more packages to this task by just modifying it slightly. So I'll just go ahead and delete the package name and change this to a variable called item. I'll change the state to installed, and then I'm going to include a with items here. And now I can go ahead and just list out all the packages that I want to install. So this basically allows me to have three tasks in one, because if I were to write it out, I would have to do yum name equals package name, state equals installed or latest, and then do that three separate times. This allows me to loop over it so that all three packages are installed in one task. Now you can use with items with pretty much any list, so files, users, things like that. But like I said, I typically use this with packages all the time. So just exiting out of here, and I'm going to open up another file called loops.yml. And another loop option that I want to show you is with dict, which lets you iterate over a dictionary instead of a list. And if you remember from our YAML overview lesson, a dictionary is just key value pairs, so our loop would include both of those items. And we can use a with dict example to print out some Ansible facts about the environment. So looping over environment facts, debug message equals item.key equals item.value. And then we'll include the with dict to do Ansible_env for the environment. So these are facts gathered using the setup module. And there are many facts that have dictionaries associated with it, and Ansible-env is one of them. So I just want to show how that's going to look when we run the playbook in a bit. So another loop option. With Ansible, you also have the ability to loop over files, and there are a few options for that. We have with files, with file glob, and with first found options. And an example of iterating over a file pattern with file glob would look something like this. So I'm going to loop over some files and then copy. So I'm going to use the copy module, set the source to a variable, item, the destination to a directory that I want to go to here. So that's going to be temp loops, which is a directory that I created on my target machine. And then I'm going to use the with file glob option to grab a pattern. So temp wildcard.conf, close my quotations. And so this is where, again, using the copy module, the source is where it's located on my target machine. So locally here in my temp directory, I have just a few comp files that I created and a few text files. So by including this pattern here, it's only going to copy over the configuration files instead of the text files as well. The last loop option that I want to show you is something called a do until loop. And this is basically used when you want to keep checking for a condition until it is met. And I'm just going to show you kind of an arbitrary example here. So do until something, shell echo hello. I'm going to register the output of that. I'm going to retry it 5 times with a delay of 5 times until output.standardout.find hello is not equal to -1. And that should do it. So I'll go ahead and save this out, and now we can run the playbook. So Ansible-Playbook-I hosts loops.yml. So it's going to start with the setup, and it's going to print out my environment facts. So you can see here, it's giving me key value pairs. It's going to then loop over those files in my temp directory and copy them out, which it's doing here. And then my do until something is showing a changed, meaning that I echoed hello and then it stopped executing the loop. Blocks are new as of version 2.0 and allow you to logically group together tasks and apply certain directives to them. This is useful with conditional statements and privilege escalation sections that apply to multiple tasks. For example, using our mariadb.yml file, I can actually place the entirety of my tasks into a block. And I've actually already done that in this playbook to show you how it looks. So if you see my block keyword here, I've placed all of the following tasks inside of the block. And then, still inside of the block, I have a conditional statement that applies to all the tasks in the block. And I set become yes to all the tasks inside of the block. So, by blocking off these tasks, I can now apply privilege escalation and a conditional statement to the whole block instead of to each task one at a time. This means that I can have two blocks in a playbook with one that targets Ubuntu hosts and one that targets RHEL and Cent hosts, and only have to include two conditional statements at the end of each block, which will save me a ton of time. Not to mention that I don't have to become the root user arbitrarily for the whole play and just apply that to specific block tasks as necessary. So, blocks also work terrifically with error handling. And I have a file here called blocks.yml that we're going to use for some practice. I can add a block with a task, a rescue section just in case something goes wrong, and an always section, which will happen whether there are errors or not. And so this is going to look something like the following. So I'll just do name, copying in a block, and then I'll put my copy task in here. The source set to temp test1.text, destination equals temp loops. Then I will include my rescue section here with my debug message of stop error time. And then I will include my always section with my debug message here. This message will always display. So before I move on, this is really good for error handling. So I have my task, the copy task. And if for some reason the file isn't found or the path doesn't exist or whatever, I have this rescue section in here that will display a message if something goes wrong, and then it will continue to move on to any other tasks I may have in my playbook. And the always section will always display regardless of whether there will be an error or not. So that's an example of error handling with blocks. Now I can also nest blocks, and I'll keep going. And now I will put a debug message nesting some blocks. So this is possible, block nesting, but I wouldn't always recommend doing it. This is just an arbitrary example to show that it is possible to nest them. And so now I can actually run my playbook. So I'll exit out of here and run Ansible-Playbook-I hosts blocks.yml. So it'll go through and gather facts. It's going to copy. Then I get my debug message of in the always section, this message will always display. And I get my debug message of nesting some blocks in the nested blocks section. However, if you notice, my stop error time debug message did not display because there was not a problem with the copy task. Templates in Ansible are processed by the Jinja2 templating language. The structure of a Jinja2 template is pretty broad, as Jinja can generate any text-based format into a template. You don't even need a specific file extension. However, if you do include the .j2 file extension, that helps you recognize that the file you're pushing out to your remote hosts is a template file. Now, in a previous lesson, we included a template task to copy out the MariaDB configuration file to our managed host. The file is my.cnf.j2. Notice the .j2 file extension. And if I open that up again as a refresher, you can see that I created a variable inside the file called MySQL port, which I then defined in the var section of my playbook. So templates in Ansible are just like variables in Ansible. We're essentially creating abstraction in our configuration files so that we can utilize them for as many different types of hosts as possible. And for the most part, your template files will probably just be standard configuration files with some variables in them so that you can define them appropriately based on your target host. However, if you're feeling adventurous, you can check out the Jinja template designer documentation, which is at jinja.poku.org and includes some more complicated Jinja inside your templates. So, to help you get started with that, I've actually included an example IP tables Jinja2 template file, which can be used to configure IP tables rules for a full stack application with a load balancer and a monitoring server. This wouldn't be used in RHEL 7 as Firewall D is now the default daemon, but I like this template because it showcases a few things. So, opening up the file, you'll notice the first thing we have is a variable called Ansible-managed. And this is a default variable that can actually give me info on when a file was modified and by whom. So, really useful. We're also using inventory host name, which is a magic variable that allows you to access the name of a host name as it appears in inventory. And we're also using groups, which is another magic variable and applies to all the group names in your host file. So in this case, the host file would include several groups for the stack, including a DB servers, LB servers, monitoring, and web servers group. Now, in terms of the content of the template, we're using Jinja2 decisioning to set up IP tables rules. In our first stanza, we're allowing incoming connections over port 80 if the host is part of either web servers or the monitoring servers group. And just kind of going down a couple blocks, we also set our listen port to a variable for our LB servers group. So I would have to make sure I define that in my playbook before running the Ansible command. And before I get to the playbook, the last section that I wanted to point out is the one right below it. This is an example of a Jinja 2 loop. So here what we're doing is we're looping over all the hosts in the monitoring group and listing out all the IPv4 addresses. So host pairs is another magic variable that allows you to access fact data and variables about other hosts. Now, we need to use host pairs here because this particular task is going to run on all of our servers, meaning that we need to make sure that the other hosts can access the fact data about the monitoring group. So if I want to include this in a playbook, it's going to look very similar to my MariaDB task. And I'll just exit out of here and open up my templates file, which I have started. So I said the first thing I need to do is set my listen port to 8888 for my load balancing servers. And then I would move on to my task section and include my template task. So insert IP tables template, use the template module, source, set it to iptables.j2, destination equals etc sysconfig IP tables. And then just like before, I'm going to include a notify in there to restart the services, which means that I need to have my handler section with the restart IP tables task. So name equals IP tables, state equals restarted. Now at this point, I could run the playbook to push out my template if I was running a RHEL or Cent6 host. So for those of you out there, if you want to spin a VM with that version up to test this out, feel free. Other than that though, that concludes our lesson on templates. If you recall from a previous lesson, Jinja2 is what Ansible uses to render out templates to our managed hosts. Jinja2 is not just limited to template use. You can utilize Jinja in playbooks through the use of various filters. And just like with variables and loops, there are a large number of Jinja2 filters that can be employed for your use, but we're only going to cover a few here today. If you'd like to see the full list, you can check out jinja.poku.org and search for the list of built-in filters. So first up, we have filters with conditional statements. Just going to open up my filters.yml file. Using an arbitrary example like this task here, which is going to print out the path environment variable, I can take this registered result variable and now use a Jinja filter. And this is going to resemble a Linux pipe as a variable is piped through a filter. So this is going to look like debug message equals the play failed when result pipe failed. And what this means is that that debug message is only going to display if the quick echo task results in a failure. And so going along with this theme, we can also have a debug message display if the play changed, when result pipe changed, if the task succeeds, so when result pipe success. And then lastly, if it skips, when result pipe skipped. Okay, so when I run this playbook, the only debug messages that should display are the changed and the success one. And so we'll see that in a bit. Moving on, the next filter I'm going to demonstrate is the default filter. This allows me to set a default value for a variable if the variable ends up being undefined at runtime. And so a good example of this would be I can set my host line to a variable. And if that host variable happens to be undefined, I can set a default value so that the playbook will still run. So that's going to look like quotations, curly braces. I'll call my undefined variable database host, pipe that to default. And then inside my parentheses, I'm going to put my actual host or group name, just test server, close my braces, close my quotations. And so when I actually go to run this, it doesn't matter that database host is undefined because I've set a default as a backup. And so it should run the playbook as normal. So the last filter type I'm going to discuss are set theory filters. These allow me to grab unique sets from a series of lists. Here's how it works in action. In my var section, I have two YAML lists specified in shorthand style called cheese and pizza toppings. And I can get information about these lists using set theory filters. So the first one I have is to only get the unique entries from my cheese list. So when I run it, it's going to strip out all duplicates. So what this looks like, debug message equals cheese pipe unique. And so just looking at my var section, you can see I have two instances of cheddar and two instances of mozzarella. And so it would only show each of those once. Now, another set filter that I can use is to get the items that are different from list one to list two. It's not going to show me list two items. It's just going to show me the ones that are different. So I'm going to debug message equals cheese pipe difference. And then in parentheses, pizza underscore toppings, which is my list two name. Close out the braces, close out the quotes. And then the last one that I can do is I can get all unique entries from both lists. Cheese pipe union pizza underscore toppings. And so that's going to give me a complete list. So these types of filters are useful if you're pulling from multiple similar VARs files and then need to compile it into one list and then loop over it for a playbook. There's lots of Jinja2 filters, so definitely check out the documentation and see what's out there for your use. Okay, so now I can actually run this playbook. So I'm going to exit out and do Ansible-Playbook-I host filters.yml. So it gathers facts, and then the rest of this should complete really quickly. Great. So I'll just scroll up and we can walk through this. First thing, we've done the echo of the path environment variable. And so as a result, my failed task skips because it doesn't need to display. However, the play did change and it also succeeded. So those debug messages will display. It did not skip, so that task skips. And then we have my set theory filters. So here's all my unique values for my cheese list. Here's what's different between list one and list two in my second task here for the set theory filters. And then my last one shows me the unique values from both lists. Up until now, I've been discussing Ansible key concepts and functionality while trying to simultaneously demonstrate some best practices. I want to make sure that those are clear so that when you leave the Ansible nest, you'll be ready to fly. So first things first, we'll start at the top level with your overall project structure. So I like to make sure that everything I need for a particular project is contained in one project directory. If we take a look at a tree of my Ansible project directory here, I have my inventory file, my main playbook file, which I typically call site YAML, but can be called whatever you'd like, the Ansible configuration file, a group VARs directory that contains a variable file pertaining to all of my hosts and a variable file pertaining to database hosts, and a roles directory containing all the role components that I would need to utilize in my main playbook later. This is probably the most common setup you'll see, but you may also see a host VARs directory containing VARs files that pertain to specific hosts, multiple inventory files that are separated out based on environment type, e.g., production or staging, and any custom modules or plugins contained inside a library directory. Now, if we move on to my inventory file, so far we've just been targeting the one host, so this is a pretty basic file. We could expand that to have multiple groups with hosts, as seen in my amped up host file here. And this inventory file is a good example of grouping your host together by function, i.e., web server or DB server, as well as by region, as my group names have a region prefix to make it easier for me to figure out which host I want to target in my playbook. Now, I can also group my disparate groups together by using the children option, and so that I can target all my web server groups together or all my DB server groups together. And you can keep a similar inventory format for a file that instead targets your staging instances instead of your production instances. And since you have to tell Ansible which inventory file to use with the -i flag, this ensures that you will hopefully always target your host correctly. So, in previous lessons, I had mentioned that you can set various host and group variables directly in your inventory file. But I actually think a better practice is to either utilize a group vars or host vars directory that contains vars files instead. In my opinion, this is better than muddying up your inventory file and allows you to keep your vars file separate from your main playbook. Also, because of the nature of where Ansible looks for variables, any variables in a group vars or host vars directory will automatically be picked up. All you need to do is make sure that the file names inside of these directories match your groups or hosts exactly, and then Ansible will do the rest. So, taking a look at the all file I have in my group vars folder, this would be a vars file that would contain variables that would pertain to all hosts. So in this case, I just have a standard HTTPD port variable that would apply to every single one of my hosts. But I also have a DB servers file, which would apply to any database host that I plan on targeting. And variables in here would be specifically related to the database, like you can see here with the MySQL port. Now, if you don't want variables in plain text alongside your playbook, you can use something called Vault, which we'll talk more about in a future lesson. So, moving on to my main playbook file, the following are some of the best practices that you should integrate when writing your playbooks. First, keep it simple. Ansible is just like writing an English paper. Just because you can use 4 adjectives to describe something doesn't mean that you should. So, in terms of Ansible, less is more. And don't use every feature just because you can. Second, name your playbooks so that anyone coming in will know what's happening. The same goes for individual tasks. Name them something that makes sense to everyone if they're not familiar with Ansible. Third, keep white space in between your tasks to make it easy to read. As you can see, just because I have these white spaces in between my tasks, it just makes it look a lot more formatted and it's easier to digest. Fourth, always use the state parameter. Believe it or not, this is not required in any module that uses the state parameter. So it's important to tell Ansible exactly what state you want a package to be in, either latest or installed, or especially with the service module, what state you want the service to be in. And lastly, this is less about a specific playbook and more about your overall playbooks and files. If you want to keep a history of all the changes you make to your project files, keep it in source control. And make sure when you do your commits that you're adding specific comments about what you're changing. Includes is the Ansible term for calling a playbook, tasks, or handlers file and using it in your current playbook. So, how would this look from an Ansible perspective? Let's say, for example, that you have 2 disparate playbooks that you want to run at the same time. So, you include the other playbook in your main playbook file, and then the two run back to back. Similarly, if you have a tasks file with a list of tasks you would like to use, you can include those as well alongside the tasks in your main playbooks. The syntax for this is pretty simple. Taking a look at my mariadb.yml file, which is mostly intact from all of our meddling over the past few lessons, I can actually include some more tasks using the include directive to do other things on my server. All I have to do is decide where I want my include to go in my playbook, as Ansible executes tasks in order from top to bottom. So if I put an include at the top, that will happen first. Likewise, if I put an include at the bottom, it will execute my normal tasks first and then go to the includes. The include I'm going to use here is just a tasks file with 2 tasks that install SE Linux and test if it's enforcing, which we'll look at in just a second. I'm going to place the include at the top right underneath my tasks directive. The syntax is just include and then the name of the file, which is sclinux.yml. And notice I don't have a path because it's at the same level as this playbook. So now when I go to run this playbook, the two SE Linux tasks will execute first after we gather facts, and then it will move on to the database tasks as listed here. I can also include whole other playbooks with includes if I want, especially if I'm targeting a different host in the group. So if I want the entirety of this playbook to execute and then begin on another, I can add an include at the bottom at the same level as my play header. Then I'll do an include web servers.yml, and then that will run at the end as if another playbook was starting. So I'm not going to keep this in the file when I run it though, but this is the syntax you would use if you wanted to include a whole other playbook at the end of your current playbook. Before we move on, I wanted to preview some future lessons. So include statements are considered to be the precursor to something called roles. And roles basically take the idea of including other pieces of playbooks to a new level. But I wanted to mention before we run the sample playbook that includes and roles can be used side by side. So while roles are great and you should totally use them when writing your playbooks, don't forget that you can use includes too. So let's go ahead and run this playbook so you can see how the include looks in the output. So I'll just exit out of here and save. And I'm just going to cap my SE Linux file real quick to show you that it's just two tasks. I'm installing two SE Linux packages and then testing if it's enforcing. So now I will run the playbook with Ansible-Playbook-I hosts and then MariaDB.yml. Okay, so it's going to gather facts. Then my include should happen, which as you can see, the include is listed. So it's going to go through those two tasks. Then it's going to go through the MariaDB tasks that we had already done previously. And so this should complete shortly. And once it does, then great, that's perfect. The directory structure for roles is key because by utilizing it, Ansible can automatically load VARs files, tasks, templates, and handlers, allowing you to break your playbooks into logical components that are easily shared among groups. You can create the standard role structure by using the Ansible-Galaxy command. A full list of options for Ansible-Galaxy can be found by passing the -h flag for help. To create the structure, you first should create a roles directory in which to house your roles. So then you should change into that directory and then use Ansible-Galaxy in it and then the name of your role. I'll call mine MariaDB. Now that it's created, let's take a look at what we have. At the top level, we have the name of my role, which is MariaDB. And inside that directory, we have several subdirectories, most of which contain a main YAML file. This is just a sample name that can be changed if you like, but I generally just leave it as is. So what do all these subdirectories do for you in the context of a playbook? Well, if you call the role in your main playbook, then any main YAML file with content in it will be evaluated as part of the role. In other words, any tasks or handlers or VARs listed inside those files will execute as part of the role in the same order that they would in a playbook. Likewise, if you have a file that doesn't have any content in it, then Ansible will just ignore it. Now, in terms of the individual directories and what should go and where, we'll talk about that in a future lesson. But for now, I wanted to draw attention to directories that you may not immediately recognize what they're for. So starting off with the defaults directory, this is where you're going to place any default variables for your role. And if you recall from our variables lesson, role defaults are the most easily overridden. So these are similar to using the default Jinja filter. Just define variables in here as a backup plan, just in case the variables don't get defined elsewhere. The files directory is where you would place any files needed for your roles. These could be scripts, configuration files, RPMs, etc. And note that if you're not templating the files using Jinja, then they should probably go in the files directory. The meta directory is where you're going to place your role dependencies. However, that topic requires a bit more detail, so we'll talk more about that in a future lesson. Lastly, we have the test directory. As of Ansible 2.0, Galaxy has integrated with Travis CI to automate the role testing process. By default, a test directory is now created that contains a localhost inventory file as well as a basic playbook that's going to target your local machine and test your role. So if we take a look at those really quick, you can see that all it is it's just showing a local host targeting in my inventory file. Similarly, my test.yml file is just targeting locally and running the role. Now, testing roles with Travis is a great habit to get into. So if you already use it, I would definitely utilize our built-in functionality. So if we take a look at the playbook file, we're going to strip away the pieces and place them in the appropriate files in our rule structure. So first things first, the only place where we need a play header, i.e. the name of the play, the host declaration, and any other options is in our main playbook file. So we're going to leave this alone. The next thing we have in our playbook is our vars file that we're using. I can actually go to this file and take the two variables listed here, and then those would go in my vars main YAML file. So I'm going to exit out of here, and I'm just going to cat my Maria vars file, copy these two variables, and then I'm going to open up the roles MariaDB vars main YAML file and place these two variables right in there. And then I'll just close out. And then I can actually remove the vars file from my project directory, as well as remove the vars file header from my main playbook. I'll go ahead and move this file out into a test files directory. Opening up my main playbook file again, I'm going to remove the vars file directive. The next thing we have is the include, but I'm actually going to skip that for now. We're going to get into what to do with the include later on. So next up are our tasks. And luckily, the role structure is pretty self-explanatory. So these tasks are going to go appropriately inside of the tasks main YAML file. And I'm no longer going to keep my tasks inside the block since I already set become yes in my play header and I'm only targeting this one host. To save time, I actually already moved these tasks over so that you guys don't have to see me unindenting this entire block of tasks after I paste it. So I'll exit out of here, save that, and I'll just show you that tasks file, which is in roles, MariaDB, tasks, then main YAML. And then there are the 4 tasks listed there. Now, the second task here, which pushes out my MariaDB configuration file, we had the template file that's just residing in the same directory as my main playbook file. But now what I can do with it is I can actually move it into my templates directory, which I'll do now. mv my.cnf.j2 into roles MariaDB templates, and then that will go in there. Now, lastly, if I open up my main playbook file again, the last thing I have is the handler section. And just like with tasks, the handler sections appropriately go in the handler's main YAML files. So I'm just going to copy and paste this task here, exit out of this file, and then I'm going to open up roles, MariaDB, handlers, and then the main YAML file here. And then I will paste this, make sure that my service is at the same indentation level as name, and then that's good to go. So I'll save this. That's an example of breaking up an existing playbook into the role structure that we had created previously. So what if you want to do this with making a role from scratch? I'm actually going to cover that in the next part of this lesson. So just feel free to go right on to the next video, and then we will cover that topic. This is part 2 of breaking a role into a playbook, where we will now cover how to create a role from scratch. To start, I need to add another role into my roles folder, which I'll call a common role. This type of a role is something you might see if you have servers with different purposes, i.e. web servers or database servers, but you still have tasks that would apply to both of them. So I'll just use the Ansible Galaxy command and create my common role. Now, this particular role is where I'm going to utilize my selinux.yml file that I included in my MariaDB playbook from earlier, which, as a refresher, the file just installs selinux and checks to see if it's enforcing. I'm still going to make this file and include, but I also want to create another tasks file and include that. This sounds confusing, so let me go ahead and create my task file and go from there. And I'm going to call my tasks file ntp.yml. So I'm just going to create that. And in here, I'm just going to place some tasks to install and configure NTP. So name, install NTP, yum, name equals NTP, state equals present. My second task, configure NTP file. Use the template module with the source set to ntp.conf.j2. with the destination set to etsy.ntp.conf. And then I'm also going to restart NTP. Then I have my start the NTP service task using the service module. Start it with name equals NTPD, state equals started, and enabled equals yes. So that is my NTP tasks file, and I'll go ahead and save that. And there are a couple things that I need to handle in here. So just taking a look at it, I have a template file that I need to move into my templates directory. I also have a notify, which means I need to place a handler for that notify in my handlers directory. And I also have a standard NTP drift file where my NTP server IP is set to a variable. So I will need to define that IP in my var's main YAML file. So I'll start with that. Need to buy that. Perfect. Let's go ahead and define that NTP server. 192.168.1.2. So I'll save that. I've defined my variable. I need to handle my handler. So I'm going to cd up one into handlers main YAML and add in my handler, restart NTP, service, name equals NTPD, state equals restarted. Save that. So I created my tasks file. I defined my variable in the var's main YAML file. I defined my handler. And so now all I need to do is move my template file into the templates directory. And I actually have that in a test files directory, a few directories up. So I'll go ahead and move that into templates. So now that I've done all that for the NTP role, I also want to move my SE Linux role into my tasks directory. And then I can include both of them to use inside my main YAML file for the overall role. So I'm just going to move this SE Linux. So if I do an ls here, I should have 3 files. And I do. And so now I'm going to modify my main YAML to include both of these files. And that looks like the same syntax as it does in a main playbook. So all I do is include selinux.yml, include ntp.yml. So when I call the role in my main playbook, it will start with the SE Linux tasks file, and then it will move on to the NTP YML, including everything that's in the task. So it would act upon the task in there, and then it would move on to the template task, which would pull in the templates file. It would move on to the handler and restart, which would pull in the handlers, and it would pull in the vars that I defined in var's main YAML. So now in our next lesson, we're going to show how to call these roles in our main playbook. I'm going to quickly show you how to utilize the roles we've created in our main playbook. Since your main playbook may include multiple roles, it's good practice to name it something that makes sense for all the roles you're utilizing, something like deploy site.yml or something similar. I'm just going to name mine site.yml, and then I'm going to go ahead and get started with my play header. So I'm still going to need to name my play. And again, you should name it something that makes sense in the context of the roles you're calling. So I will name it deploy common and MariaDB role. Then I have my host declaration line. So I'll do test server, the user I'm connecting as EC2 user, and then whether or not I want to escalate to the root user, which I do. So I'll set become yes. And then I'll call my roles by using the roles header. Right below that, I can call the roles that I want to utilize, which in this case will be the common role and the MariaDB role. And that's it. So there are a couple of variations to this that you could utilize. You could actually include multiple plays that call different roles if you have to target different hosts. So basically, it would just be this top play header here. I could put that below this section, target a different host, and then call a whole new set of roles. And I could also have more tasks in my main playbook file if I need it. And those would just go in their own tasks section that would either execute before or after your roles declaration. So kind of similar to what we did in the includes lesson, we just have to choose if we want to put our includes at the top or bottom of the playbook file if we have tasks that we have in the main playbook as well. So now when I run this, it's going to execute the tasks in the common role first, And that's going to show the included task files that we have in there. So both the SC Linux and the ntp.yml. And then it's going to move on to the MariaDB role. So I'll save this and we will go ahead and run it. So Ansible-Playbook-I hosts, site YAML. So it's going to start off with the setup, gathering facts. Then it's going to move on to the include. As you can see, there's the SC Linux tasks, which we had already done before. Now it's including the NTP tasks, which is the second include in our task main YAML file. It's going to go through those tasks. So install, configure, start NTP. Then it's going to move on to the MariaDB tasks, which we've already executed multiple times. So then our handler runs at the end. There's that restart, and then the play completed successfully. Now that we've covered how to break up a playbook into a role and how to call it in your main playbook, this lesson will cover role dependencies. As I mentioned previously, the meta main YAML file is where you would specify any role dependencies for your current role. This means that if you need a certain role to have run on your host before you run this role, then that's a dependency. The syntax for this is pretty simple. So in my meta main YAML file, I would just go to the dependency section and specify the role that I want to run. So right now I'm in the meta directory. I'm just going to open up the main YAML file and I'm going to search for dependencies, which is right at the end. Then I'm going to specify the role that I want to call, which in this case is just the Apache role. So this is just a basic example of declaring a role dependency, but if I also want to include parameters, I can make this look a little fancier and do role Apache when Ansible OS family is equal to Red Hat, close out my brackets. And that would be an example of adding in a conditional statement into my role dependency declaration. Now, by default, role dependencies are going to get executed before the role that depends on them. And role dependencies are also recursive. So those roles that you're executing can also have dependencies, which means that those would also get executed. So a good question before we move on is, why do you need to specify role dependencies at all, especially if you're calling all the roles you need to run in your main playbook? So I like to think of role dependencies as a best practice, especially if your playbooks are fluid and you're rotating out which roles you're running in your main playbook at any given time. It just ensures that you don't accidentally include a role that requires another role before running it. It's like your role backup plan. So to show you how this looks, I'm going to exit out of this file and I'm going to go ahead and create another role in my roles folder called Apache so that it won't error out on me here when I actually try to run it. So Ansible Galaxy init Apache. And I'm basically going to go into my task file here and do a few Apache tasks. Open up that main YAML file and I'm going to include some tasks in here. So first thing, I'm going to install Apache and firewalld. Yum name equals item, state equals present, with items, httpd, firewalld. My next task will be to start firewalld now that I've installed it. Service name equals firewalld, state equals started, enabled equals yes. Now that that's started, I can insert a firewall rule for Apache. So I'll use the firewalld module. I'll set the port to a variable, call that httpd underscore port. Make sure that this is permanent, set the state of the rule to enabled and make it kick in immediately here. And then my last task will be to start Apache. So I'll use that service module again. We already included this as a dependency for our MariaDB role to ensure that it gets run first. So basically, when I run it, it's just going to run the role as if it wasn't even a dependency. It's not going to indicate that it's a dependency. It's just going to run the role as if we had declared it normally in the main playbook. So I'll save this and I'm going to go define my HTTPD port variable real quick. So I'll go up into vars and open up the main YAML file there. Set httpd underscore port to 80, save that, and now I'm going to go ahead and run my main playbook file. So Ansible-Playbook-I host site YAML. It starts right away with the common role because that was specified first. But then once it gets to the MariaDB role, we've got the Apache tasks coming back okay. And then it's going to move right onto the MariaDB tasks. So that's how we know that the role dependencies kicked in. We're going to be discussing privilege escalation, or the idea of becoming another user than the one you connected to your remote host as. As we've seen throughout all the previous lessons, I've been setting become yes in my main playbook because many of the tasks I'm including require me to have root level permissions on my target host. Become yes allows my EC2 user to become the root user. So there are a few directives that you can employ in your project. Where you decide to use these is up to you, but we'll start off by looking at the privilege escalation section in Ansible config. Search for privilege in here. The first is the one that activates privilege escalation, which is become yes or become true. They're interchangeable, so you can have either. The second is become method, which we can set to something other than sudo like pbrun or pfexec. There's also become user, which allows you to become a different user other than the root user if you have become yes specified. And note that become user does not imply become yes, so make sure that you set that in your playbook. And then lastly, we have become ask pass, which will prompt the user to enter the privilege escalation password. Again, this doesn't imply become yes, so we really need to make sure that that's set if we're going to modify these values. So as you can see, these values are commented out by default. So if we just set become yes in our playbook, it's going to assume that we're escalating to the root user unless we explicitly say otherwise. And of course, this isn't the only place where we can set these directives. You can actually set them as connection variables in your inventory file, or you can pass them at runtime by adding -b for become, for example, to the end of your ad-hoc command or Ansible playbook run. Personally, my preference is to set them in the playbook, which I usually do at the play level, but if you need to, you can also set them at the individual task level. Now, before we get to how these directives look in a playbook, I wanted to outline a few things first. One, become is the new syntax as of 2.0. So if you're running 1.9, you should be declaring sudo yes or sudo method or sudo user. Sudo should still work in 2.0, but it may be deprecated in the future. So if you're starting on 2.0, you might as well just learn become. Second, make sure you're actually becoming a privileged user. If we're copying files out, for example, then Ansible has to make that file readable to everyone so that the user we're becoming can actually read it, which of course would be readable for the entire playbook execution. So make sure your user is privileged because using the root user, we've already got those inherent restrictions by being the root user. So I would definitely recommend making sure your user's privileged. Third, we can't limit privilege escalation to certain commands. So I can't say that I just want to have root level permissions for specific things on the target host. The permissions have to be general. And lastly, become methods can't be chained, so we can't go from one method to another. So now that my cautionary warnings are out there, let's talk about privilege escalation in a playbook. And I'll just open up my site YAML file here that we used previously. So we've seen become yes throughout our playbook lessons, but what about using the others? Assuming we have this play header here with our play name, our host declaration, as well as our remote user, I can set become yes, and that's going to activate privilege escalation. And then if I'd like, I can become a different user other than root by setting become user to, let's say, Postgres, and this would be a good example if I had database tasks that would require us to be the Postgres user. Or if I wanted to use a different become method, I can set become method pbrun right in my play header after become yes and become user. So I don't have pbrun set up here, but what I can show you is I did go ahead and add a different user on my target machine called Michelle that has root level privileges. So I'm going to change to that user after I connect to the host as the EC2 user. So I'm just going to add become user here, Michelle, and that's all I need to do. So I'm going to exit out of this and save, and then I'm going to run my playbook with 4 Vs, which gives me debug level verbosity so I can see the actual user change in my output. So I'll go ahead and do Ansible-Playbook-I hosts site YAML, and then I'll add 4 Vs and go ahead and run that. Okay, so I'm not going to need to run this entire thing, so I'll just go ahead and Control C to stop the execution. Right here, you can see that it starts by establishing the SSH connection for the EC2 user, which remember is the user that we're connecting as. But then it's going to move on to the user that I'm telling it to do the other tasks as, which is the Michelle user. And you can see here with this command that it's basically switching to the Michelle user. I've got the echo become success message here, which means that it switched to the Michelle user successfully. Occasionally, you may have the need to assign a task to run on a specific server rather than the one you've been targeting in the rest of your playbook. This is called a delegate because we're delegating a task to a specific server. Use cases for delegate include disabling monitoring alerts on one server, removing a server from a load balancer pool, templating out a file to another host than the one you're running the playbook on, or really anything that requires you to delegate a task on a specific server. For our purposes, a common task would be a restart task, followed by another task that waits for that service to come back. So if I open up my test delegate playbook here, already got it started. So I'm going to start with the restart task, restart machine. I'm going to use a shell command to sleep for 2 seconds. And then I want to issue a shutdown command with the -R for reboot and make sure that that happens now. And I'm just going to put in here a quote about why we're restarting the computer. And then I'm going to add a couple parameters. So I've got async 1, pull 0, and ignore errors set to true. The async and the pull settings means that we're allowing the task to continue on in the background so that we can move on to our next task. And the pull number of 0 means that we're essentially firing and forgetting this task since we don't care how long it takes to complete. We just want the reboot to happen. We're also setting ignore errors to true because we don't want the task to fail if there are things that still need to close out on the target host before the reboot kicks off. So our next task is our waiting task, waiting for server to come back. And for that, we're going to use the wait for module. So host equals inventory host name. So that variable that utilizes the host name as it's listed in inventory. We're setting the state to started because we want the machine to be started. We're going to set a delay equals 30 and a timeout of 300. And basically, what those mean is that we're going to wait for 30 seconds before we start the timeout, which is set to 300. So the timeout of the task to overall timeout, which would be 5 minutes. And then I'm going to set become to no because I'm going to delegate this task to localhost. And so we don't need to escalate to the root user on our local machine. Before we move on, why are we delegating this task in the first place? Remember that we're rebooting the machine in our first task. So we're going to lose the connection to that host, and we want a way to keep the playbook going, hence our delegate wait for task on local. So basically, while the machine is going through its reboot procedure, we're just waiting for it to come back, and then we can kind of move on again as necessary. Now, we can actually shorthand this task by using something called a local action. And so I'll just write this out and we'll comment it out later. But if I wanted to shorten this, I could do local action, wait for host equals inventory host name, state equals started, delay equals 30, timeout equals 300. And then I would still set become to no. This is just shorthand syntax for a delegate on a local host. We're going to keep the delegate theme going here. So I'm going to delete this guy because we're not going to use it. We're just going to use the delegate. But just know that if you are delegating to localhost, then you can use local action instead. And so that's kind of how the two can be used synonymously, but I don't necessarily have to delegate to localhost. I can delegate to anybody. So that's just an example. I'll go ahead and delete this guy. And before we move on, I did want to just show you one other feature that's new as of 2.0. This is something called delegate facts. I'm going to make a new play called testing delegate facts. And I'm going to set the host to test server again and remote user, EC2 user. Yes. Get my task section going here. I'm going to gather local facts and I'm going to use the setup module for that. Delegate locally. Again, I can use local action there if I want to. And delegate facts true. And what delegate facts true does is it basically allows me to actually gather the facts about the machine that I'm delegating to, because by default, even on delegated tasks, facts gathered there will be assigned to the original host and not the one that we're delegating to. To get around that, we're setting delegate facts to true so that we can gather facts from the delegated host instead. So this is all we're going to need for our playbook here. And I did want to mention before we run this that wait for task will probably take upwards of 5 minutes. So through the magic of editing, it's going to appear to be much shorter, but I didn't want to have you sit here for 5 minutes watching a blank screen waiting for the task to finish. Just keep that in mind when you're watching it. It does usually take about 5 minutes, hence the timeout setting. So I'll save this and then I'll do Ansible-Playbook-I hosts test delegate, and then we'll go ahead and run this. So we're starting off gathering facts on our target machine. We're going to do the restart, which should come back as okay because it's just a shell task. And now we're going to wait for. So at this point, I'm just going to be quiet and we'll wait for the task to complete. After that very long delay, we can take a look at the task completion. And as you can see here, it's showing that the original task has been delegated to localhost. Then the same thing with our next play, the testing delegate facts. It's starting off by gathering facts on the target machine, but then we're gathering local facts and delegating those locally. And you can actually jazz up your playbook even further by adding a register to the end of your delegate facts and then debugging the output so you can see the facts gathered locally. Error handling is a broad term to cover ways to handle potential failures in your Ansible playbooks. In our previous lesson, we actually used ignore errors set to yes to handle our reboot task just because we wanted to make sure that the task would happen just in case. The one main caveat to ignore errors is that it has to be a failable task. Connection errors will not work with ignore errors because we need to be able to complete the task and return a value of failed. To show an example of this, let's say that I wanted to create a user, but I want to make the user's password a variable. So I could have a task like testing ignore errors. I will set the username to Michelle P and the password equal to a variable uPassword. And then I'll set ignore errors to yes. And just for good measure, I will include another task in here so you can see that it does actually ignore it. So when I run this, it is actually going to give me a failure message that the uPassword variable is undefined, but it will move on right to my next task and it's going to list ignoring because we have ignore errors set to yes. I'll do that now so that you can see how it looks. So I'll exit out of here and do Ansible-Playbook-I hosts test errors. There's the fatal message, but you can see the ignoring right there. And then the next task was just an echo hello world, which returns changed, and the play continued on as if we didn't have the failure at all. So going back into my playbook here, another example of error handling is actually controlling what defines failure. And for that, we would use failed when. And failed when is useful if you're running a command on your machine and you're looking for a specific return code, or if failed shows up in the output, you can actually have failed when with those conditions to ensure that the task fails. So using an arbitrary example, we're actually going to modify the Jinja default filter example that I did many moons ago, and we'll use failed when on that one. So I'll do shell echo path, register the output of that. And then I will have a debug message here. Stop running playbook if the play failed. And then I'll include failed when, result, filter, failed. This particular task will not fail because all we're doing is just echoing an environment variable. But what you could do is you could have something like echo failed, shell echo I failed. We'll register the output of that. Now we'll have another debug message. Okay, really stop the playbook. And we'll include failed when output.standardout.find. And then we're looking for that failed string. And so basically the playbook will stop executing if it finds failed string in the output. So what I want to do is I'm just going to add in another task to show you that it will stop. And we'll just do another echo hello world. So now on the other side of failed when, we have the ability to override the changed result of an Ansible task with changed when. And remember that with the exception of the command, shell, script, and raw modules, then modules will return okay if they have nothing to modify. If we want to keep that sense of idempotency on our shell tasks, we can actually add changed when set to false so that it will display okay instead of changed. I'll go ahead and go to my quick echo and I'll just set changed when to false so that now it will display okay instead of changed. And you could actually couple this with a task to do a modification if you receive a return code after the fact. But in our case, we're just going to add the changed when here. And so now we can go ahead and run this playbook and talk about the output. So I'll use my Ansible Playbook command again. We're going to gather facts. We've got our ignore errors, our echo hello world. Then here we have the failed when, where it actually shows the failed when result is set to false. Again, I mentioned before that it's not going to fail because all we're doing is echoing the environment variable. And you can also see that the quick echo is set to okay because we added the changed when instead of having no change when. So that would report as changed normally. So then our next echo is reporting as changed. And now the playbook completely fails out because it found the failed string inside of our echo command. And so it completely stops the playbook execution. And so that last echo hello world does not execute. Even with Ansible's idempotency, it's a good idea to do a dry run of your playbooks before trying to run them first. You can do that with check mode, which you can run by passing -- check to the end of your Ansible playbook command. Only modules that support check mode will show you what would have happened when you pass -- check. Anything else is just not going to report the changes that they would have made. A drawback of check mode is that things that depend on previous tasks are going to fail when you run it in check mode, where they might not have otherwise. Keep that in mind if you're utilizing check mode to see if your playbooks are going to fail. Sometimes they will, whether they would have in real life or not. I added another role called PHP into my roles folder that just contains a single task that installs 3 packages. So just showing you this, I'm installing PHP, PHP MySQL, and Git with the Yum module. And I went ahead and called that role in my site YAML file. So now we can run it with -- check to see what it looks like. So I'll do Ansible -playbook -I hosts site YAML -- check. And you can see that it basically looks like a playbook run because it's going through the tasks, but the Yum install actually takes much less time since nothing is installed. And I can confirm this by running an ad-hoc command to try to remove one of those packages I just pretended to install. If it was there, then I would be able to remove it. If it's not there, then it should show me that it wasn't installed. So Ansible test server -I hosts -U EC2 user. Use the Yum module, pass it some arguments, go ahead and run that. And it's saying PHP is not installed. So that's good since we did run it in check mode. Now, check mode is also good to at least show syntax errors if you have them. So if I modify my site YAML file, I can create a syntax error pretty easily. And then I can rerun this again in check mode. And it points out the syntax error right away. And it gives me the general location of my syntax problem. So, this is a good start to the overall process of debugging playbooks, which you will most definitely have to do while you're learning Ansible. But let's also talk about some things that you might run into as you're going out into the world and writing your own playbooks. A common issue that many people run into prior to even writing playbooks is an SSH connection error. This is typically pretty easy to fix unless your environment is hardened in some way. But for the purposes of testing Ansible, there should only be a couple things that you need to look for. Case in point, if I run an ad hoc command like so, the big difference between this and all the other ones is that I'm not passing the -U flag for remote user. I also don't have that set as a variable anywhere else. So when I run this, which will take a couple seconds to return, Ansible is not going to know what user to connect as, so it's going to fail. And the error you usually get is data could not be sent to the remote host. Make sure this host can be reached over SSH. Now, when I'm troubleshooting SSH errors, I can crank up the verbosity of this command and add 4 Vs to the end there. And right away, we can see that it says establish SSH connection for user none because Ansible doesn't know which user we're connecting with. And eventually, we get a message that says to please log in as a user, EC2 user. So we're getting a helpful message that, hey, you should probably let us know that you're connecting as EC2 user. Alternatively, if SSH inbound access is limited to your host, you may get a connection timeout error. So if I actually go to my security group for this host on the AWS side, I can edit the inbound rules to a custom IP. And I'll just put in kind of an arbitrary example here and save that. And then I'll go back and I'm going to add my user this time. I do want to have that in here, but now it's not going to be able to connect at all because my IP is different from the custom IP that I just set. And so there you go. So I get the connection timed out error right there. So generally speaking, you should start any SSH connection troubleshooting by first attempting to SSH to the host directly. And if you're able to do that, then it's probably just a matter of specifying the user you're connecting as with Ansible, whether it's in your playbook or in inventory or as -u with an ad hoc command. So I'm just going to go back over to my inbound rules and change this back to anywhere and go back to my terminal. This actually concludes part one of our lesson on check mode and debugging playbooks. Feel free to proceed right on to part two, where we'll look at correcting syntax errors. This is part two of our lesson on check mode and debugging playbooks. Previously, we discussed check mode and troubleshooting SSH connection errors. The second thing that you may see a good deal of when you're attempting to run playbooks are syntax errors. Like I mentioned before, you can use check mode to go through the syntax errors as you get them, but sometimes it may not be immediately apparent what the problem is from the message. So to show you a few examples, what I did is I added some minor errors to our test errors playbook that I ran a couple lessons ago, and we'll go through these one by one to correct them. So if I do Ansible-Playbook-I hosts test errors, immediately my failure appears to be on line 7, column 2, and it says the offending line appears to be tasks. So it makes me think that something's wrong with my tasks header. So if I open up the file, I can see actually that there's an issue with my indentation. So a lot of times with syntax errors, make sure that things are indented properly. And in this case, my tasks is over one too far. So all I have to do is do one indent and then it's good to go. So I'll escape and then we can rerun. The next message I get is related to unbalanced Jinja2 block or quotes. So I do have quotes in my debug messages, so I want to make sure that those are accurate. So I'm going to go in here again and kind of take a look and noticing right away that this debug message does not have a close quotation. So if you are using the debug module and passing a message, make sure that you close your quotations out. Otherwise, you'll get that message. So I'll edit this, close that out, and rerun. So now the playbook's actually running. We have our ignore errors, which is just going to continue on. And so now I have another message that says error while evaluating conditional, error output is undefined. From my playbook, I know that I did a register and called that variable output, but I want to make sure that I didn't mistype something somewhere. So I'm going to go back in and go down to my echo failed task and compare it with my debug task. And I can see, aha, that I added an extra S onto outputs where my failed when message was just a singular output. So all I have to do there is change this. And then now that task should continue on successfully. So I know that this last one isn't a typical syntax error because it doesn't fail the playbook out immediately, but mistyping variable names is bound to happen. So it's always something to look for when you're debugging your playbooks. So other tips to think about. Ansible actually has some handy built-in directives that will allow you to focus on specific tasks if you're having issues. So the first example is something called start at task, which will start at a specific task instead of having to run the whole playbook just to get back to the task that's failing. And so to show you an example, Ansible-Playbook-I hosts test errors. And then I would add start at task and set that equal to the task name. And so I'll do quick echo, and then we can go ahead and run this. Oh, my bad. I actually have to put that in quotations because there's a space. So there's another example of debugging. So I'll go ahead and run that, and it should start right at quick echo. And it does after it gathers facts. And so then it continues on. And I'm just going to Control C out of this since we don't need to continue. So another option is that you can pass dash dash step to your playbook run to have it prompt you interactively on each task, which is a handy way of breaking things down. So all I have to do is add step to the end there. And then basically it's going to prompt me for every single component of the playbook with yes, no, or continue. So do I want to gather facts? Yes, no. So I'll do yes. Do I want to test ignore errors? Yes, no, or continue. And if you do decide to do continue, that just means that the rest of the playbook will continue without you prompting. Okay, a couple last things. Anytime that you need to see more details on what's happening under the hood with your task executions, crank up the verbosity level, add, 2, 3, 4 Vs to see what's happening. So we did that with the SSH connection troubleshooting, but you don't have to limit yourself to just that. You can do that with pretty much any task. And lastly, not that you should need any reminder of this given how often this has come up, but use the debug module to debug any variables you set. It's really helpful to see how things are actually getting passed between tasks. In this lesson, we're going to be talking about managing Windows instances with Ansible. Now, the setup process is a little different with Windows than with Linux hosts. So I'm going to walk through the whole process from prepping my Windows system to creating the inventory file and then to running a playbook. However, anything that doesn't seem clear, I've listed steps in an accompanying text document for you to follow along. The first thing that I need is an actual Windows host to manage. So I went ahead and launched a stock Windows Server 2012 R2 EC2 instance. Out of the box, the Windows instance will have the remote desktop protocol port open, but we also need to add inbound rules for 5986, which is our WinRM connection port. You can see that I've already done that here. We need that port open so Ansible can talk to our Windows host. Once that's set, you need to download some sort of remote desktop client if you aren't using Windows. I'm using Microsoft Remote Desktop for my Mac because I just need to run a PowerShell script on that machine to configure it to talk to Ansible, and then I can go back to my Vagrant instance. To be able to connect, you'll need the default Windows password, which you get when you click connect. And then you would copy and paste in the contents of your private key to allow you to decrypt the password. And that shouldn't be too difficult since we already put that into our Vagrant instance. So just copy and paste that in to get the password. And then you can configure your desktop client. So I'll switch over to that, which is right here. And if I click edit, you can see that I gave it a connection name. I added the username, which is administrator, the default password, which I decrypted and put in here, and then the public IP address, which is listed here. So now I can actually go ahead and open up the box. And that brings me into my Windows Server machine here. And so I'm going to go ahead and open up a PowerShell window. I need to change our execution policy from restricted to unrestricted because right now by default, I'm not going to be able to execute any scripts. So I'm going to do set execution policy unrestricted, press Y. Okay, that's good to go. And then once that's done, I'll go ahead and open up Notepad and I'm going to copy and paste the raw version of the configure remoting for Ansible script that goes through everything that needs to happen in order to get Ansible to talk to this host. So I'll just go ahead and pull that up just over here and I'll copy this guy, go back over to my host and I'll paste it in. Save this file with the PS1 extension, save. And then I can go back to my PowerShell window and run it. So just press enter there. And it's okay. So everything's good to go. For those of you who are interested in what the script is doing, it's just checking some basic conditions. So whether I have the correct version of PowerShell, whether WinRM is listening, and then it goes and configures WinRM to listen over 5986. Luckily, this script is ready for us to use and we can just run it and start using Ansible with Windows right away. So now that I've executed it and it came back okay, I can go right over to my Vagrant instance and start the configure process for my inventory file and inventory variables. So, unlike managing Linux instances, I'm connecting over WinRM and not over SSH. So, I do need to set some inventory variables to let Ansible know to not do its normal default behavior. So, I prepped my Vagrant box a little bit by creating a new project directory called Windows. And inside that directory, you can see that I moved my Ansible config file over. I have a group vars directory and a hosts file. And inside of my group vars directory, I have a file called Windows. And this is where I'm going to place my inventory variables. So I'll just go ahead and open that up. We'll get these in. First thing I need is the user, which is administrator. And then I need the password, which is super secure as I type it out here. And then I need the port that we're connecting over, which is 5986, as I specified in my inbound security rules. The connection type, which is WinRM. And I'm going to set the server cert validation to ignore. And that's all I need for my inventory variables. Now, just to preview a future lesson, there is a way to mask this password so it doesn't appear in plain text. And we'll talk about that in a future lesson. So I'll save this here. And then I need to go up one and modify my host file, which I already have a Windows group in here to match my group vars file. But now I just need to input the public IP address. So that is 52.34.191.78. Save that. And if everything has gone according to plan, I should be able to ping my host now to see if we have connectivity. So I'll do an ad hoc command for that, which is just Ansible Windows -i host -m. And then the ping command is actually prefaced with win instead. So it's a win ping instead of just a regular ping. And if we get a pong, that means that we're good to go. So I'll run this. And I got a pong back, which means it was successful. So now what we can do is we can write a playbook to utilize some Windows modules. And that actually concludes part one of our lesson on managing Windows instances. So you can feel free to go on to the next video where we'll actually write that Windows playbook. This is part two of our lesson on managing Windows instances with Ansible. In our previous lesson, we went through the process of prepping our Windows host and setting up our inventory variables and host file. We also confirmed connectivity to the host with WinPing, so now we can actually go through the process of writing a playbook. I did want to mention before we get started that our Windows support is improving, but we do not have nearly as many modules for Windows as we do for Linux. So it's a good idea to check out the module index to see a full list of the Windows ones. And I actually have that listed right here. You can see we have the Windows modules, and here's a full list of the ones that you can utilize. If there isn't a module out there for what you need yet, there are a couple workarounds that you can utilize. So the first thing is you can use the raw module to issue commands on your Windows machines, kind of similar to using the shell module that we've employed in previous playbooks. You can also write PowerShell scripts and push those out with the script module. So there are kind of a couple ways around the lack of Ansible Windows modules. That's not to say that this is a huge improvement over just a couple versions ago. More and more people are coming to the fold. If you're handy with PowerShell, feel free to submit a PR to get some more Windows modules in here. Switching back over to my Vagrant machine, I want to actually go ahead and write a playbook now. So I will make a new one called windows.yml, and I will go through the process and make my play header. This is pretty similar to a Linux playbook, except I don't have to put as many things in here. So I'm just going to do Windows for my host, and then don't need to specify a remote user because I already said that I'm connecting as the administrator user in my group vars file. I also don't need to do any sort of privilege escalation because the administrator has full privileges already. So I'm good. I can pretty much move right onto my tasks section. And actually, before I do that, I'm just going to toss a var in here because I'm going to use that later. So I figured I might as well put it in here now. Perfect. So first things first, to kind of show you an example of that raw module workaround I mentioned, let's say I want to run ipconfig on my machine. I can just do raw ipconfig, and then I can register the output of that. and I'll debug it so that we can see the output of the IP config. I can also use the WinStat module to give me some info on a file. So that would be WinStat, pass the path. So I will do windows.winInI, close that out. I'll also register this and we'll debug the output of that. And then another common use case that you might see is you might want to add a local group, add a user to that group, and then add some permissions. So I'll do a task add a local group, use WinGroup module, name equals test Windows group, description equals my Windows group, state equals present so that it actually gets added. And then I'm going to move on to adding a local user. So I'll use the WinUser module. I will call my user test user, set the password to a variable, which I've defined up top. And then I will set it to the group, which is test Windows group. And then I'll do a group action to add it like so. Now I'm going to give my local user some permissions. So I'll do WinACL module for that. I'm going to kind of do the shorthand version here and do my parameters underneath the module like that. So I'm going to enclose my path in quotes, and then I'm going to double escape it just because when I use the colon key value pairs, I just want to make sure that YAML doesn't interpret my path with the colon in it incorrectly. So I'm just going to double escape it. Close out my quotes. My user is test user. I'm going to give my user full control on that directory, and then I'm going to allow it. Type allow. And so now I can actually run the playbook. So I'll exit out of here, and it's the same command, Ansible-Playbook, Windows-I host, and then Windows.yml. Oops, I got all excited for a second. I was pretending that I needed to do an ad hoc command when all I really need to do is pass the host file. There we go. Perfect. So I'll go ahead and run that. So we gather facts. And the setup module is native to both Windows and Linux, so you can gather facts on both types of machines. There are less facts gathered with Windows, but it's something to think about if you're using facts as variables, things like that. It took a little bit to gather some facts there, but now we're going to run ipconfig. Great. So there is my debug output of ipconfig there. Pretty much what you would expect. So now we're moving on to testing the stat module on the file. So remember, that was the task where we were just gathering information about the WinInI file. And so we're going to get some information about that in our debug. Okay, and so there is my debug information on that file. So I get information like the creation time, the last access time, last write time, who the owner is, the size of it. And so now we're moving on to the local group task. And that came back as change. So now we're going to go ahead and add a user to that group. And that also came back as change. So now we are going to give that user some permissions. And that completed as well. So we gave that user some permissions, and now the playbook has completed successfully. And that concludes part 2 of our lesson on managing Windows instances with Ansible. Up to this point, we have been manually managing our inventory in our any formatted host file. However, since that host is actually from AWS, I can use the EC2 external inventory script to manage my hosts instead. This is more in line with best practice since hosts are typically coming and going fairly frequently on the AWS side, and it's a hassle to manage manually. That's really all the dynamic part of dynamic inventory is basically that we're updating hosts on the fly as we need it. So the steps to setting up dynamic inventory are as follows. First, you need to place a copy of the ec2.py and ec2.ini files inside your project directory. So I created your directory here called ec2, and inside that, all I have right now is a key pair file and a library directory, which we'll talk a little bit more about later. So I need to go ahead and get those ec2 files. So I'm going to switch over and go ahead and grab those. This is the ec2.py script here, and you can see that I have the raw version from GitHub. So I'm just going to copy that, make the file, paste this guy, and there's a fair amount of logic, hence why the file's a little bigger. I will save this, and then I'll switch over and go to ec2.ini and copy that, make a new file, and save that. Now, the ec2ini is basically like the inventory file for EC2. So here's where you can filter hosts and regions and things like that. We're really not going to touch this file at all, but I did want to show you that it's best practice to have that file alongside the ec2.py as well. So now that I have those two files placed here, I need to do a change mod plus X on the ec2.py to make it an executable. And so now I have those two files good to go. And then I need to move on to my next step, which is to make sure that Bodo is installed, which I can install with pip install Bodo. And so I've already done that here, but I did want to show you that that would be the command that you would use. And so then you need to get your key pair from Amazon. So I'll switch over and go to my IAM management console, which you can get to by clicking on your name in the upper right-hand corner and then clicking on security credentials. That will take you to this page. You're then just going to click the plus icon next to access keys. And if you don't have one created here, you would click create new access key and then download your key pair and keep that somewhere safe. Now, what we're going to do with that key pair is we are going to export them as environment variables so we can test our connectivity with Amazon before we get to the playbook. The important thing to remember with that, though, is that these environment variables will not persist outside of this shell session unless you set it in the user's profile. So we're really just using this export right now just so I can test that we can actually talk to Amazon. So I'm going to cat my key pair file since I have those in there, and that'll make it a lot easier for me to export since I have them right in front. So export AWS access key ID, set that equal, and then paste that. And then I'll do the second one, export AWS secret access key equals, and then I should be good to go. So now I can confirm that I can list out our current instance with /ec2.py -- list. And so this will take just a couple seconds. Okay, great. So this output is basically giving me everything about this particular instance that I have launched. So you can see we have the IP address, we have the platform, we have the DNS name. So these are things that I can leverage in Playbooks to modify on my instance or to use as facts. But what about actually creating a new EC2 instance? And so that will actually be covered in part 2 of our lesson. So feel free to go right on to the next video where we're going to write a playbook to utilize some EC2 modules. This is part 2 of EC2 Dynamic Inventory with Ansible. In our first lesson, we covered the setup process and we were able to confirm connectivity with Amazon by running /ec2.py -- list. Now we're going to make a new playbook. So the first thing that you need to know about provisioning a new EC2 instance is that we need to target local host in our playbook since we don't have a host created yet. So let's go ahead and make a file. I'll just call it playbook.yaml. And I will call it launching an EC2 instance, host localhost. I'm going to type connection local, really make sure we've got that connection local thing hammered home. And I'm going to set gather facts to false because I'm just targeting locally, so I don't need to run the setup module. Then I'm going to bring in that key pair file. So I'm going to call it as a vars file because many of the EC2 modules require you to have the EC2 access key and the secret key as parameters for the modules. So I have them placed in a key pair file that I'm just bringing into the playbook like this. So I've got my key pair set there, and now I'm going to start with my tasks. All right, so the first thing that I want to do is I actually want to go out and find a RHEL 7 machine to target, and I'm going to use the EC2 AMI find module, which is new as of 2.0. If you take a look at examples out there, a lot of them have an AMI ID already specified, and if you don't happen to know what AMI ID that you want, it's a good idea to use some of these fact gathering modules so that we can get information, register that output, and then use it as a variable in the next task. So we really never have to leave the playbook in order to get the information that we need in order to launch our instance. So I will call my task, search for the latest RHEL 7 AMI, And then I'm going to use EC2 AMI find region. I'm going to use US East 1. I've got my owner ID here. So this is the standard one for the RHEL AMIs. Okay, and that should be correct. And then I'm going to filter by a name. So what I'm going to do there is I'm going to kind of do a pattern. So I'm going to do rel-7.2, and then I'm going to wildcard it, close my quotes. So this will allow me to get rel 7.2. And then there's all this extra stuff at the end, telling me about the virtualization type. But since I don't know that offhand, I'm just going to add that wildcard indicator so I can grab all of them. And then I'm going to register the results. So find results. And you guys know the drill at this point. So I'm going to debug that. Now, in the future, I have these debugs here as kind of a placeholder. So when I first start these playbooks, put the debug in to see what I'm getting. And then you can always take them out later once you know. You don't have to keep them in. I just like to show you what you're seeing from the tasks. So I've got that debug. And so what I'm going to do now is I'm going to build on that task even further. So I'm going to try to find a subnet ID. I know in advance that I want to have a public IP address to target in the future. But in order to do that, I need to have a VPC subnet ID when I actually use the EC2 module in my next task. So since I don't know the VPC subnet IDs by heart, I mean, who does, right? I'm going to use EC2 VPC subnet facts module to gather some facts about the possible subnets in my region. So I'm going to exit out of this real quick because I want to talk about this. For those of you keeping score, this module is actually a 2.1 module, which means it has not yet been released. I wanted to show this to you because it's a neat, handy trick. Basically, what you can do is create a library directory directly adjacent to your playbook. So right here, it's at the same level as my playbook.yml. And inside the library directory is the EC2 VPC subnet facts module file. So I grabbed the raw version of that from GitHub and just placed it in here with the same name. And so now I can call that module from my playbook, even though it's not out yet. Now, this isn't always going to work, especially if there are incompatibilities between the new version and the old version. But 2.1 is pretty close to 2.0, so there's not any differences that I need to worry about in the library, so I'm good. So now I can actually use this unreleased module in my playbook to help me out. So I'm going to go back into my playbook file and I'll go to the end and I'm going to use that module that I put inside the library directory. So I'm going to call my task name, find a subnet ID. I'm going to call EC2 VPC subnet facts. And so now this is where I need to bring in my variables. So I've got AWS access key as the parameter name. So for that, I'm going to use my variable names, which are EC2 access key. Close that. Then AWS secret key, which is EC2 underscore secret underscore key. And now I'm going to use the region again. So US East 1. And again, I'm going to register. So subnet IDs, I'll do another debug. And so now I've gathered the AMI IDs and the subnet IDs. I can actually launch an instance using the good old classic EC2 module. Here we go. Launch an EC2 instance, use EC2. And again, I'm actually going to copy this and put it down here because it's the exact same parameters. So now I'm going to add in my instance type, which I'll do a T2 micro. Use the region, US East 1. And now for the AMI ID, I'm going to use a variable and use the results from the EC2 AMI output. That's going to look like find underscore results dot results, which is the name of the dictionary that it returns. Then the first value in that dictionary dot AMI underscore ID, which is what I'm looking for. I'll close that out. Okay, I'm also going to tag my instance because I am definitely a fan of that. I'm going to wait for the instance to be running before this completes. And now I'm going to assign that VPC subnet ID. And again, it's going to look similar to this one. So my variable was subnet underscore IDs. The dictionary that returns is called subnets. First position in there, dot ID, which is what I'm looking for. Close that out. I will assign a public IP to my instance. And now I should be good to go. So I'm going to save this and let's go ahead and run it. So it'll be Ansible-Playbook and I'll just do playbook.yml. So I'm going to start off. So I'll scroll up a little bit while this is thinking. So here are the AMIs from my find. So you can see here we've got the AMI ID, which is what I'm pulling. And then if I go down, I've got my subnet IDs, which returns that subnet dictionary. And now I'm just waiting on the launch EC2 instance task. And now that's completed, which means I should be able to go over to the AWS side and confirm that it's there. So I'll go to EC2 and I'll switch over to US East. And then there's my running instance. Now, this is just a quick sample of what's possible with the EC2 modules, but I did want to point out that this is the full list of all of the Amazon EC2 modules that you can utilize. So get out there and Ansible all the things. In this lesson, we're going to be talking about Ansible Vault. Vault is a feature that allows you to encrypt files with sensitive data in them rather than keeping them in plain text inside your projects. Now, in our previous lessons on Windows and EC2 Dynamic Inventory, I had the default admin password and my EC2 key pair unencrypted, so pretty much anybody coming in has that information. And since that's not the best idea, I figured it would be good to show how to use Ansible Vault to encrypt those files. So I'll start with my key pair file. To encrypt an existing file, you would use the command Ansible Vault encrypt and then the name of the file, which is keypair.yml. So now I'm prompted for a password, which I'll enter. And now it's saying encryption successful, which basically means that I can no longer view this without entering my Vault password. So if I'd like to edit it or view it, I can do Ansible Vault edit key pair, enter my password, and then now I can actually go ahead and modify this as necessary. It would be the same command to view it. It would just be view instead of edit. Now, to actually run a playbook with a Vault file, I could do Ansible-Playbook, the name of the playbook, and then I'm going to add ask Vault pass to ask me the Vault password interactively. So I'll enter that in. So now it's basically going through my playbook since it was able to find my key pair. So I'll exit out of that. I don't need to keep that going. And that's pretty much all there is to it. Now for my Windows project, I did something a little bit different. So I'm going to go into my Windows directory here. I'll go into group vars, and I'm just going to ls this really quick. And this is a little different than it was when we first did this lesson. So best practice for variables in Vault is basically that I'm going to create a directory underneath my group vars directory called Windows, so it should match what the group name is in inventory. And then inside that subdirectory, I created two files called vars and Vault. And our vars file is actually all the variables we had specified previously. So I'll just cat this real quick. Except now I set my Ansible_user and Ansible_password variables to variables that I'm going to place inside my Vault file. Those are the sensitive variables that I probably want to mask. So that's why I split them out like this. So I'm going to go to the Vault file and add in those variables. So Vault Ansible_user, administrator, Vault Ansible_password, and I'll just type the password out here. Perfect. And I'll save that. And then now I'm going to encrypt that file with Ansible Vault encrypt Vault. And the encryption is now successful. So now I can go up a couple directories and then I can run my playbook. So Ansible-Playbook -I host windows.yml -ask vault pass. And then it basically begins going through the playbook just as if we had normally run it. Now, Ansible Vault is very useful, but if you have a lot of files to decrypt at runtime, you might consider installing the cryptography package with pip. So the command for that is just pip install cryptography, and that's going to help speed up the decryption process at runtime, especially, like I said, if you have a lot of Vault files that you're decrypting. And I'll cancel out of that, and that pretty much covers our lesson on Ansible Vault. I'm going to briefly discuss some Ansible resources you may want to explore now that you guys are well on your way to being Ansible pros. And before we get started, all the links I'm showing here are going to be listed in a document for you, so you don't have to scramble to write these down. First, there's the big kahuna, which is docs.ansible.com. Here, you're going to find documentation on every topic I've covered, plus all the documentation on the individual modules, which can be found in the module index. You can also head to ansible.com/resources, where you'll be able to find some old webinars, some of which star yours truly. And you can also check out the white papers and case studies from other companies that are currently using Ansible. Third, for a collection of sample playbooks that you can use to get started, I would check out our Ansible examples repo. I tend to use these in my semi-monthly webinars, and they're really handy in showing a swath of Ansible functionality, specifically the LAMP HA proxy example or the LAMP simple rel 7. It may also be worthwhile, speaking of Ansible repositories, to keep the Ansible, Ansible Core, and Ansible Extras repo links ready to go. So the Ansible/Ansible repository is for the core application, and the core and extras modules are for anything module related. If you have a module that isn't working the way you think it should and you think it might be a bug, or if you'd like to submit a pull request or a feature idea or a documentation improvement, then these would be the areas to check out. So we did talk about this briefly in previous lessons, but if you're interested in getting started with the roles functionality beyond what we covered in our roles section, you can check out galaxy.ansible.com and download some roles that you can use in your test environments. You can do that by going to Browse Roles, and they have the most popular roles listed there that you can check out. All right, and lastly, what if you have questions? Rather not what if, but when you have questions, where would you go? So a really good resource for that is the Ansible project mailing list. This group is really active, so don't feel afraid to use it and ask questions to get input on your playbooks or just general use case scenarios. Welcome to our final lesson in our Introduction to Ansible course. Since we've come so far, I did want to take this opportunity to review our objectives that we discussed way back in the beginning. Our first objective was that you, the learner, would be able to install and configure Ansible and be able to create a basic playbook that utilizes different Ansible functionality. So in our setup to configuration section, we covered the process of setting up your test environment to installing Ansible and then going into the main pieces you would need to be able to talk to your hosts. We then built on that foundation in the next section by writing a playbook and showcasing Ansible key concepts like loops, conditionals, and variables. Our second objective was that you should be able to implement Ansible best practices after completing the course. Throughout the course, I attempted to showcase best practices organically by weaving it into the lessons. However, the last lesson of our Ansible to Ansible-Playbook section covered playbook best practices specifically, and we talked about ways to improve your playbook runs in our two-part lesson on check mode and debugging playbooks in our continued look into playbooks section. Our last main objective is that you should be able to recognize potential use cases for your own environment. Use cases were sprinkled throughout all our lessons, but specifically our lessons on roles in our includes and roles section, and our targeted lessons on Windows and EC2 dynamic inventory in our special topics section should help you figure out how to organize your complex playbooks and the type of inventory you want to manage with some tips and tricks for good measure. So with that said, give yourselves a big round of applause and a hearty huzzah for completing this course. And I did want to take this opportunity to thank you for watching my videos and for joining me along on this Ansible ride. So now it's your turn to go out there and be Ansible ninjas.